Hello, fellow Java developers. What if I told you that you could start building AI-powered applications today without needing a PhD in machine learning or months of studying neural networks? My name is Dan Vega, and I love Java, Spring, and AI. Like many of you, I watched the AI revolution unfold and thought, this is amazing, but how do I actually use this in my Java applications? That question led me on a journey, and today I'm excited to share what I've learned. Here's the reality: most AI content is either too theoretical, Python focused, or requires deep machine learning knowledge. But as Java developers, we don't need to train models from scratch. We need to integrate these powerful AI capabilities into our existing applications using the tools and frameworks we already know. The AI landscape is moving really fast. Companies need developers who can implement these AI features, and the good news for you is you don't need to switch to another language or become a data scientist. With Spring AI, your existing Java skills are exactly what you need to build production-ready AI applications. So if you're ready to add AI capabilities to your Java applications, you're in the right place. Let's dive into the course overview and I'll show you exactly what we'll cover. All right, welcome to this course, AI for Java Developers, Building Intelligent Applications with Spring AI. My name is Dan Vega. I'm a Spring Developer Advocate at Broadcom. I'll tell you a little bit more about me in a minute here. So why are we here talking today? We are talking about Spring AI, and recently Spring AI hit 1.0 GA, which means it is generally available. We hit that 1.0 milestone, and I'll leave this. If you go over to the spring.io blog, there's a really good post on kind of the efforts that went through this. And we also did a really interesting interview with Mark Pollock and Christian Tozoloff on the Spring Office Hours podcast about the 1.0 release. So if you're interested in hearing more of the backstory and how we kind of got here, you can take a listen to that. So I want to start with an introduction, just kind of who I am and what we're going to do in this course. Again, you can skip forward. There'll be timestamps below, but I think some of this is going to be important, so try not to go too far. Just really quick about me. My name is Dan Vega. You can learn more about me at danvega.dev. I'm a husband and a father. We live outside of Cleveland, Ohio. I'm a Java champion. I've been doing this for 24 years. Oh, I hate putting that number up there. It makes me feel old. I've worn a lot of hats in this industry. One of my favorite is the one that I'm wearing right now, which is that of a Spring Developer Advocate, because long before somebody was paying me to do so, I have been an advocate for Java and Spring. One thing I like to share with you is that you don't need permission to advocate for the things that you're passionate about. You can, if you like a particular tool or a framework or a language, go talk about it. Give a lunch and learn to your office, give a meetup in your local community, talk at a conference, create a video, write a blog post. Share the things you're passionate about. You never know where that's going to lead you. I'm also a soon-to-be author, The Fundamentals of Software Engineering from Coder to Engineer. I am writing that currently. We are kind of in production with that. That is with my good friend Nate Shuda. And we will be doing some talks later this year, depending on when you're watching this. I believe that the fundamentals of software engineering are more important than ever. I think some people are going the other way and saying, I don't need to know the fundamentals. And I completely disagree with that. So I think this is a timely book. If you're on the O'Reilly platform, you can go ahead and get it in early release now. I mentioned this thing called the Spring Office Hours a little bit ago. This is a podcast. This is a way for us to kind of keep everyone up to date with things that are going on in the Spring ecosystem. It's not just Spring Framework and Spring Boot. It's not just Spring AI. There are a ton of projects in the ecosystem. And we have interviews with Spring team members. We talk to different guests. And we try to keep you up to date with everything that's going on. So if you want to learn more about that, it's a free resource, springofficehours.io. Another free resource is the Bite-Sized AI newsletter. You can learn more about it at bitesizedai.dev. This is a newsletter that I put together to just write about the things that I find interesting in the world of AI. and just give me a reason to kind of stay up to date on everything that's happening. So again, another free resource if you're interested. Okay, so I think we need to start with an agenda. What are we going to cover in this course? So I want to start with what is AI. We are going to jump into a little bit of theory and just talk about some of the terms that you're going to come across. I think AI is kind of an umbrella over a lot of different things, a really broad discipline, and there are some things that matter to you when we get into like generative AI. So we'll talk about things like machine learning and deep learning at a high level. I just want you to understand what these things are, so when they come up in conversation, you understand what is happening there. So we'll talk about some things in AI. We'll also cover some like important concepts like prompt engineering. So we'll take a look at that, as well as like large language models and some other things. So once we do that, we'll go into getting started. I want to talk about like getting started with, okay, I need an API key for something like OpenAI. How do I do that? We'll talk about how to create a new project using the Spring Initializer. We'll talk about how to like write your first application that talks to a large language model. And then we'll kind of cover some other things there. But this is going to be very much a project or code that we are working on together. There'll be some code throughout the course that I might just show, but early on, we're going to write a lot of this code together. And then we'll jump into some of the Spring AI features. So I think one of the things that you'll hear me say a lot throughout this course is that if all we needed to do was hit the REST endpoints of these large language models and get a response back, we wouldn't need frameworks like Spring AI. But Spring AI is much more than a facility for making REST calls. It is a way to solve a lot of the problems that are going to come up as we start to build Gen AI applications. So we know about proprietary models like OpenAI's GPT 4.1, 3.0, 03, all of them. There are other frontier models out there like Anthropic Claude and Google Gemini. There are also open source models out there that you can run on your local machine and not share any of your data with some of the big companies out there with. So we'll take a look at some pros and cons, how to run them on our local machine, and even how to use those models then in our Spring applications. LLMs are great. They have some limitations. They have things like hallucinations and not being able to get current events. So we need to figure out how we can augment these limitations. So we'll dive, this is going to be a really fun section. We're going to dive into things like prompt guarding and stuffing the prompt and RAG and tools and MCP and a whole bunch of stuff. So I'm looking forward to that one. Observability, a big important feature. You don't know you need it until you need it, right? Observability has kind of been rewritten in Spring Boot 3.0 and above. So 3.0 kind of rewrote the observability story, and every kind of release since then, there's been new features for observability. Each of the projects in the Spring ecosystem kind of tap into that observability. And Spring AI was no different. So now you get some really good observability on like what kind of requests are being made, especially when we start talking about tokens. Like we'll learn more about tokens as we get into this, but how many tokens on average am I sending to a large language model? How many of those are prompt tokens? How many of those are completion tokens? These are answers that you're going to want or questions you're going to want answers to as you're starting to build these generative AI applications. We'll look at evaluations. So it turns out testing large language models is pretty difficult. It's not that easy, right? There are two sides of this. Deterministic, where we kind of know what the output is going to be. That's a little bit easier. But when it's non-deterministic, we don't know what the response is going to be. How do we test that? So Spring AI gives us some pretty nice features for doing that. And then we'll take a look at a conclusion. We'll kind of wrap this up. We'll take a look at some key features. We'll talk about what's next. I'll tell you what I'm working on next. And then I'll give you some resources. These are really good resources to take what you've learned and continue learning. And yeah, so I'll give you a whole bunch of really good stuff. So once you finish the course, don't skip the conclusion because there'll be a lot of good stuff in there for you to get. All right, so I think just as important as what we are going to cover, I think we should talk about what we're not going to cover in this course. So you should be comfortable with Java. We're not going to dive into any Java fundamentals. You should be comfortable with Spring and know the Spring basics. We are not jumping into anything advanced here. This is really just another vertical integration piece, right? Like if you want to talk to a database, you reach for something like Spring Data. There's a programming model there. You can go ahead and take advantage of Spring Data and do some really cool things. This is another vertical, right? Like now, instead of talking to a database, we're talking to large language models. And in that, there's a familiar programming model. And we are now just taking advantage of another vertical. So if you know the Spring basics, you should be able to get up and running with Spring AI. We're not going to dive deep into any machine learning, deep learning, neural networks, natural language processing, any of that AI theory. We're going to talk about it as a high level so we understand it in conversation, and that's really it. We're not going to build our own LMs. We're not going to fine tune our models. We're not going to talk about how we get this into production. We're just kind of laying the groundwork for building these generative AI applications. So we're not going to comprehensive coverage of all AI providers. It seems like a new provider comes out with a new model every week, and now it's the latest and greatest. The benchmarks say so, but we're not going to do that. We're going to look at like one. I'll talk about this later, but one of the really cool things about Spring AI is that you can kind of just swap models out. So we're writing code that is not model specific. So if you want to go choose Google Gemini, you can just do some configurations and do that and change that. So you don't have to change code. We're going to get into Retrieval Augmented Generation, or RAG for short, as we get into the LLM limitation section. We're going to look at a very basic example. We're not going to get too deep into vector databases and how they work and some different like search functionality we could do. We're going to look at a very basic example to augment an LLM. And then we're not going to get into complete MCP specification. Again, we'll mention MCP. We'll look at an example of MCP. We're not going to go too deep down that rabbit hole of MCP and agents. That's for the next course. So if you're interested in that, let me know in the comments below. So I think I have some tips on how to get the most out of this course. So there are timestamps. Jump to specific topics as needed. But again, if you are new to AI, I would suggest just trying to go through the kind of AI theory stuff and understanding some of these things at a high level so that you know what they are in conversation. There's a whole bunch of resources. There'll be some in the conclusion. There'll be some links and documentation and code in the description below. All of the things that we're going to show off today, you should have access to. I want you to learn, build, and share. Apply each of these concepts immediately in your own project. Try not to watch the entire course at once and then do stuff. As we kind of do things, how can I use that immediately in one of my own projects? And again, a lot of this code we're going to do together. So code along if you can. If you got 2 monitors, you got 2 laptops, whatever, put me on one and start typing on the other. Pause and experiment. So when you get through a certain thing, pause it. Let's try and, you followed along with me. Now try to do it yourself. Maybe try to build out a little feature. Pause and experiment along the way. There's a really great community called the Spring AI community that will be in the resources for this course. Really great place to kind of ask questions and share some of the things that you're doing. Start with simple use cases, build a basic chatbot before getting into something more complex. I like to keep a little journal for learning. Note your ideas as you, for projects that you might want to do on your own as you're watching along. I like to watch in segments. 1 section per day is better for retention. I know this when I go to conferences and I sit through just those like 45 minutes to an hour. I'm like overloaded. And then I go to the next talk and now I'm overloaded again. So maybe break this up, take what you've learned, kind of apply it, and then come back the next day and watch another section. We are going to prepare our environment together. So we'll talk about how to get an API key, how to kind of use that in your Spring app, how to create that initial Spring app using the Spring initializer, and make sure we have everything ready to go so we can follow along. Build a portfolio project. Create one substantial AI-powered app by the end of this course. I think that's a pretty cool goal to have. The Spring AI reference documentation is really great. So we're going to see it. I'm going to show it off a lot throughout this course. It'll be in the resources. I would keep it open. That is a great place to kind of cross-reference things. Share your progress, tweet, posts, LinkedIn, whatever you want, Blue Sky, about what you're building for accountability. And if you're doing something based on this course, let me know. Tag me in your tweet. I'd love to see that. And then focus on your domain. Think about each feature applies to your specific industry or work, and maybe a hobby project or something like that. How can this apply to what you're trying to do? So quickly, just some prereqs. Hey, we need to be familiar with Java and Spring. We need to have an IDE or a text editor, something to write code in. I'm going to use IntelliJ, but you can use whatever you'd like. Resources, my website, the Spring AI reference documentation, and then this is going to be the repo for all of the code that we're going to go through in this course, the Spring AI workshop repo over on github.com/Dan Vega. That's where you'll find a lot of the code. But again, we're going to go through this together. So I just want you to have that as kind of a backup. All right, with that, I think we are ready to dive in and start talking a little bit about what is AI. I think a really good place to start is with the term artificial intelligence. We hear this term thrown around a lot these days, but what is it? We're going to talk about AI at a high level. We'll talk about machine learning and deep learning, where LLMs or large language models fit into that. And once we do that, we'll cover some things like prompt engineering, which I think is one of the most fundamental skills that you can have as someone leveraging AI or building intelligent applications. Prompt engineering becomes very vital to that. We'll talk quickly about Java and AI. Where does that fit into it? And we'll talk quickly about Spring AI, and then we'll jump into basically getting started and writing some code together after that. While artificial intelligence has seemingly worked its way into every conversation we have, it isn't new. Computer scientists have been chasing this dream since the 1940s or 50s, when computers filled entire rooms and had less processing power than the phone in your pocket. Research in AI has progressed in waves of excitement, followed by AI winters where progress stalled and funding dried up. Then, in November of 2022, OpenAI released ChatGPT to the public. Within 5 days, it had 1 million users. Within 2 months, 100 million. Suddenly, AI wasn't just a research curiosity, but a tool anyone could harness. So when it comes to answering the question, what is AI? There isn't a simple answer because it's such a broad discipline. AI is an umbrella term that covers everything from simple rule-based systems to neural networks that attempt to mimic how the human brain processes information. So to keep this relevant to us as software developers, we're going to focus in on a specific set of techniques that have proven effective at solving some very interesting problems. Learning a new technology can often feel daunting, particularly when it comes to mastering all the terminology that can be found in a new domain. In AI, you'll encounter terms like machine learning, deep learning, generative AI, and natural language processing. At its core, modern AI teaches computers how to recognize patterns and make decisions based on data, unlike traditional programming where we would write step-by-step instructions. Now, as a software developer, you don't need to become an AI researcher, but understanding these core concepts will help you integrate AI capabilities into your applications. And more importantly, I think communicate effectively with others like data scientists and AI engineers on your team. So let's start with machine learning. Like many of the names in the field of AI, the term machine learning isn't very helpful. It suggests that we can just put a machine in a room with a bunch of books and it learns on its own, and we know that's not the case. So I think a really good place to start is to learn a little bit about machine learning and what it is and how it helps us. So machine learning is the foundation of modern AI. Instead of explicitly programming every decision, machine learning learns from patterns of data. The classical example, and I'll touch on this again when we take a look at some more examples, is the facial recognition software. You don't write code to describe every possible face. Instead, you feed the system thousands of face images, and it learns to identify patterns to make each face unique. Inside of machine learning, we really have kind of these three categories. So we have supervised learning, where the system learns from labeled examples. This can include classification and regression. In classification, we have categorizing input data into predefined classes. We have unsupervised learning, where it identifies patterns in unlabeled data, such as clustering similar data points. And in reinforcement learning, the system learns through interaction with its environment. So if you ever hear those terms within machine learning, those are just kind of the different ways that ML learns. So let's talk about some use cases to kind of bring it to reality, to things that we might come across every day. So we mentioned facial recognition. If you go on like Facebook and you add a whole bunch of photos, it's probably able to label those for you because it had enough labeled data on that. You picked out your mom and your sister and your grandparents and you labeled them. And after a while, it had enough data now. And anytime you add new images, it can go, okay, I know who those people are because I have enough data on them. We can recognize tumors on x-ray scans. So if we feed it enough x-ray scans and say, this is a tumor, this is a tumor, this is not a tumor. Sorry, I had to do that. You can do that. And with enough of those, now we can introduce new x-ray scans without any labels on it. And the machine should be able to kind of recognize those patterns. Same thing with things like abnormality on ultrasounds. Self-driving mode is interesting. We give it enough stop signs as it's driving the car through the streets. It can realize that, hey, I need to stop here. Things like fraud detection, we've seen enough examples of what a good transaction is and what a bad transaction is, and we can start to identify fraud. Again, with credit scores and loan approvals, we can kind of automate that. If you go to YouTube, you're served a bunch of recommendations on what you might want to watch next. That's because it's collected enough data on you. It knows what you're interested in, so we could recommend the right products. And if you go to your email, we can filter out spam because we know which ones you're telling us are spam and which ones are not. And the same thing happens in like a Google ranking. So with supervised learning, again, we label the training data. I label these three images on the left. I give it this new one on the right, and it should just be able to tell me who the person in that photo is because we have enough data on it. So that's machine learning. Now, all of this is made possible because of another technique called deep learning and neural networks. If you look at a human or an animal brain, you'll see that it contains enormous amounts of nerve cells called neurons. Those nerve cells are connected to one another in a vast network called a neural network. Turns out the human brain has something like 86 billion of these nerves. Pretty crazy. So how does that work in machine learning? Well, it turns out we can implement this in software. So deep learning is a subset of machine learning that uses artificial neural networks with multiple layers, hence the word deep. And these neural networks are inspired by the structure and the function of the human brain. Now, imagine a neural network in a complex web of interconnected nodes, similar to neurons in a brain. Each connection has a weight that strengthens or weakens the signal passing through it. As the network processes data, it adjusts these weights, effectively learning from the information. What makes deep learning powerful is its ability to automatically extract features from the raw data. For example, in our image recognition example, the first layer might go through and detect edges. So I'm detecting edges on this image. The next layer might start to recognize shapes in the image. Deeper layers could identify more complex features like the eyes or nose. The final layer might put it all together and classify the entire image. So all of this has happened simultaneously at very, very fast speeds. So the idea of building a computer network that looks like a human brain has been around since the 40s, since that first picture I showed you. It was only this century that it really became possible, and it really was down to three kind of key advancements. So we had some scientific advancements in deep learning. We had the availability of big data. It turns out you need data to configure these large neural networks. So in some cases, the more data that we threw at it, the better results that we got. And you need lots of compute power to configure these networks. So these were the ingredients that are really starting to make AI possible. And a particular type of computer processor is really good at doing all the mathematics to build these neural networks. You need a lot of compute power to do this, and this has all been supercharged by the GPU. So the availability of big data combined with the compute power and the GPU really starts to advance this technology. Okay, so those are machine learning, deep learning, a little bit of an overview on AI. Now let's get into some of the things that are really going to kind of bring generative AI home. And this starts with large language models, or LLMs. So let's start here and kind of get a big picture of this. So around 2017, we started seeing a flurry of AI applications. What launched all of this was probably one of the most important papers on AI in the last decade. This came out of Google Brain, which is their research labs. All 8 of those individuals on that paper have all gone on to start their own companies. And what this technology is designed for is something called a large language model. We didn't know kind of at the time, but it was this structure that made LLMs possible. And it turns out that, so introduced in 2017, the key innovation here was something called attention mechanisms. And this allowed the models to understand context by focusing on relevant parts of text, similar to how humans read text. And this laid the groundwork for more powerful language models. It turns out that it's not just a big neural network. We had a specialized architecture for token prediction. I'm sure you've heard of the term token. If you're not, don't worry, we're going to go through that. But the key innovation here was attention mechanisms. This allows the model to focus on different parts of that input when producing each part of the output. It's like being able to selectively concentrate on relevant words when forming a response. It's a novel way to look up words in a sentence and assign weights to those words. And this transformer architecture is a type of neural network designed that revolutionized natural language processing. So let's talk about how LLMs actually work. So we start with some input text. You go to ChatGPT, you type in some text. The cat sat on and this is the raw human language, right? From there, we tokenize this. So the machine tokenizes this, right? So it will break this into pieces. So the cat sat on and it turns out it doesn't like to deal with language. It actually likes to deal in mathematics. So computers work with numbers, not words. That tokenization happens and they're assigned IDs, and these are numbers, and then the machine will work with that. Once it has that, it will use the neural network to do pattern recognition. So I have all these words. Let me find the patterns. Let me find the relationships within those tokens. Finally, based on that, it can do some prediction and say, Matt, with 87% confidence, that is the next word in this particular sentence or anything it's trying to create, right? So the key insight here is that LLMs are fundamentally pattern matching machines that predict the most likely next word based on patterns learned from billions of text examples. That's why when you kind of hear some of the things coming out of the world these days where it's like, oh, the machine is reasoning and it's thinking on its own. It's not. It's not at all. This is pattern recognition, being able to kind of define the next word. Now, we can do a whole lot of things to get better results out of that. But at its core, this is what we are doing. So it says based on billions of text examples. So how are these LLMs learning? What is the training process for them? So we start with pre-training, which is the foundation. This is massive text data sets, books, web, code. It's essentially trained on the entire internet, except for everyone filing lawsuits and saying don't include our data set there, right? So lots and lots of text and data. Now, if you want to do some research on where that data is coming from, there are some interesting things on how that happens, but I don't want to get into that here. Learning general language patterns, predicting next word billions of times, and it develops a broad knowledge base based on all of this data. Then we have something called fine tuning, which is a specialization of a particular large language model. And maybe it has some task-specific data sets that are added to it. Maybe there is some human feedback training. So if you've ever been on, say, ChatGPT and you were offered two choices, like which one did you like better? That is you basically providing some fine tuning to these models. Safety and alignment, making sure it can't just break and do anything. And then adding these like conversational abilities where it says like please and thank you and has the ability to like have a conversation with you. So as a developer, the takeaway here is LLMs aren't programmed with rules. They learn from patterns and examples. And this is why they can be creative, but also unpredictable, right? So now that we know a little bit about ML, DL, large language models, maybe this makes more sense now. When we hear the word GPT, so generative is what the large language model is doing. It's able to generate new content. Pre-trained, so the P is for pre-trained. We know how large language models are trained now. They're pre-trained on vast amounts of data, essentially the entire internet. And then transformer is that special technology that came out of that deep research paper from Google for the transformer architecture. So when you hear GPT now maybe that makes a little bit more sense. So transformers provide the architecture, how they process language, pre-training on vast amounts of data. Generative capabilities allow them to create new content. And we know if you've used these products out there, we have key capabilities. I can generate text, summarization, writing, translation. We can generate new code and analysis, complex reasoning, and problem solving. And I just listed kind of the big ones here, OpenAI, Anthropic, and Gemini. But there are a lot of really, really great models out there. All right, so as we learned about earlier in this course, there are some terms that make working with AI a little bit intimidating, and this is just another example of that. Prompt engineering is just learning how to effectively communicate with AI. Think of it like learning how to use a search engine when it first appeared. It is a skill we all need to develop, but it's not something that is reserved for specialists. So imagine you're at the office, you turn to a junior developer in the next cubicle, and you ask them to fix a login bug. Without context, this simple task can become a very complex one, right? They might start wasting time searching through the ticket system for open issues. Since there are multiple login forms, which one of these needs fixing? They could spend hours testing the logging system, finding that nothing's wrong with it. But what if instead you turned to your colleague here and said, the login form on the user dashboard isn't validating email formats correctly, allowing users to submit invalid email addresses that are causing issues downstream. You would get much better results from this interaction. And the same happens with large language models. The more context we can give them, the more output direction we can give them, the better results we're going to get. So I like to say this is just learning how to effectively communicate with AI. Clear communication is key, just like with humans. Structure determines success. Giving context, examples, and specific instructions really help. I like to think of this as teaching, not commanding. I'm trying to teach a large language model what I am trying to get out of it, not saying, go do this and you better come back with a great response, right? So again, if I turned to a colleague and said, write a blog post about AI, they're going to have some questions. How long do you want this blog post to be? How many, who's my intended audience? What level, what tone and style should I have, right? So a better way to kind of phrase this would be write a technical blog post explaining neural networks to junior developers and focus on some practical examples. So I want to dive in and kind of talk about these with some examples. So clear communication is key. If you want to get good results from AI, you need to be specific. This is a technique you will learn over time by iterating on your prompts when you don't get that desired output. So bad prompt, write some Java code for sorting. Good prompt, write a Java method that sorts an array list of employee objects by their salary in descending order. Include error handling for null inputs. The second prompt gives AI everything it needs: the specific data structure, the sorting criteria, the order, and even an edge case to consider. Like writing a good article, a well-structured prompt can help an AI understand not just what you want, but how you want it delivered. So let's talk about a bad prompt. Explain database indexing. That could be open to many interpretations, right? But what if I came back and said, as an experienced Java developer, explain database indexing in 3 parts. I want to know what indexes are and why they matter for performance. I want to know when to use clustered versus non-clustered indexes. And I want one practical example of creating an index in PostgreSQL. Keep each section to 2 to 3 sentences and include one code example. So this is really good. Once you have this foundation, we can explore specific topics in more depth. This is a really great start and much better than simply explain database indexing, right? So once you've mastered the basics, these advanced techniques can really help you tackle more complex development tasks. So we're going to dive into each of these, but zero-shot prompting, this will contain no examples or demonstrations. So when you hear someone say, hey, I just zero-shotted this application, that's really what they're saying. They didn't provide any kind of context or examples for the LLM to learn from. One shot, hey, I'm going to provide you a single example of some code that I wrote, and I want you to write this in a similar manner. Few shot, I'm adding more than one example. We have chain of thought, or you'll hear this in the reasoning models, right? Something that instead of just providing an answer right away, it wants to think through it step by step and formulate its thoughts before going through with any action. Then we'll look into some like organizational techniques. It turns out like if you put your prompts into XML tags or some other delimiter, it can help structure complex requests by separating the different types of information, like do this first and then that and then that. And then that also works with task decomposition. So I have this big problem. Instead of just throwing a huge problem at an LM, I'm going to break those down into certain steps, like, hey, do this first, then do that, and then do that. It actually helps the results that you're going to get from an LM. All right, so zero-shot prompting. Asking the AI to perform without providing any examples. There's nothing wrong with this approach, and there are times when this will give you exactly what you're looking for. So I have an example here. Create a Java class that implements the observer pattern for a stock price monitoring system. The observer pattern is something that it's already kind of trained on, right? It understands this, so it can one-shot this. Other examples of this are like, hey, what if I just wanted an answer to a math problem or a historical question? I don't need to provide examples of this. It can work this out on its own. Here's a one-shot prompt. Hey, maybe I provide a single example to establish a pattern that I'd like it to follow. Here's an example of a coding style I prefer. I want this find user by email, and if it's null or it's not empty, go ahead and return an optional of empty. If not, use the user repository and find by email. So basically what I'm saying is now create a similar method called find user by ID that takes a long ID as a parameter. But now that I've given it this coding style, I should kind of get similar results. I do this a lot with testing as well. Hey, look at the test that I provided for widget A. I'm now creating widget B. Follow that similar pattern, and this could be one shot or few shot, and create a new test for this. So it can follow your kind of coding standards and conventions when you give it examples. Few shot, this is good when we want to do something like a sentiment. Like I want to classify the sentiment of the customer reviews. So I give it some examples, like the software is intuitive and saves me hours of work. This is positive. Now I could be pulling these out of my actual reviews. So if I'm doing this for like my YouTube channel, I might pull out a bunch of reviews and say, well, I said this one is positive, this one's negative. And if I feed it enough of those examples, and then I say classify the rest of these, I don't have to go through and manually classify these. It should be able to determine the classification of this review and future reviews. All right, so if you're a good mentor for a junior developer, you wouldn't just walk over to them and demand a result on a specific task. Instead, you would give them as much context as possible, teach them through examples that might already exist in your code base. Instead of commanding results, as I said earlier, try to guide the AI through your thought process. And this approach is really called chain of thought prompting, which leads to more accurate responses. So a bad prompt, optimize this code and paste your code in there. That's not a lot of context or what you're looking for, right? A good prompt might be, I need to optimize this Java method that searches through a large data set. First, help me identify the current time complexity, then suggest specific improvements. Finally, show me the refactored code with comments explaining the performance gains, and then paste your code in here. So this is much better. Instead of just optimize my code, like what are you trying to optimize? I'm trying to optimize a method. This method actually takes in a large data set. Those are two key pieces of this. It knows now that, hey, I'm trying to optimize something that takes in a large data set. There is probably some time complexity in here, right? Going back to kind of the fundamentals of software engineering that you might have learned in school, right? So this is another good kind of advanced technique. So again, as I said earlier, XML tags help structure complex requests by clearly separating different types of information. Instead of just a big block of text, the large language model now sees this and sees different sections. It says, okay, this is the task. I see some requirements. I see some constraints. By giving me these kind of clear separations, I can formulate a much better result. Then we have task decomposition. Let's break this down into manageable pieces. I'm building a file processing system in Java. Help me break this down. Instead of just saying, build me a file processing system, there's a lot that can go into that. And without the right context, you could get a really good result, but it may not be what you're looking for. So phase one, design the file reading strategy. Are we using streaming versus batch? Should we create the validation logic, implement the error handling logic, add unit tests? So we start with phase one, handling the pros and cons of each approach for processing 1 gigabyte of files. And this is better than just trying to like throw everything at it at once and end up with probably what's going to be a bad result anyway, and then have to iterate on that. So I hope that helped. I'm going to give you some more practical tips for immediate improvement. Again, be specific about context, use examples, give context about your environment. Maybe say, hey, mention your version of Java and Spring. Specify a role when applicable. This is a big one for me. Give the AI a specific persona or expertise to embody. For example, act as a senior Java architect reviewing this code, or act as a performance optimization expert analyzing this query. I can't stress this enough that you need to have some patience and understand that this is an iterative process. You need to be able to iterate and refine on this. I remember the first time, I don't remember exactly what I used for. I remember early on using ChatGPT and just thinking like, wow, this is terrible. Like, okay, yeah, cool, it can write, but I'm not getting the results that I'm looking for. And a lot of these things that we've talked through will help, but being able to iterate on this, and when you get good results, go ahead and saving those good prompts. That's the last one. Using AI to improve your prompts. I do this a lot too. Here's a prompt that I have that I think is pretty good. I will ask AI to go ahead and examine that and see if there's a better way, a better prompt that I can come up with to get the results that I'm trying to get to. Yeah, and again, save good prompts, save the ones that work work well for you. You'll likely need similar requests in the future. There are some really good guides out here. There are 3. I'm going to put a bunch more in the resources that you'll find at the end of this course, and also in the slides. And I think I'm going to try and put like a whole document together that has this in it. But there will be much more than this. But these are 3 really good guides. The prompt engineering guide at promptingguide.ai. OpenAI has a cookbook. There's a prompt engineering guide from Google. I know there's one from Anthropic. So there are some really great guides on here. And again, bang for buck. As someone who's going to be working in AI, this is probably the best place to focus your efforts. Get good at clear communication, taking advantage of some of these advanced techniques, and learning how to communicate with AI, because this will take you a long way. All right, so in that vein, now that we know a little bit more about prompt engineering, and then we need to supply as much information as possible, and that this is an iterative process. I imagine speaking to a coworker where you have a problem that you're trying to solve. You wouldn't just say, go write this code, right? How many times have you been in a chat, whether it's Slack or Google, and you just start typing to someone and you're like, oh my gosh, I have to explain so much to this person to get them to get on my level and maybe complete the task that I'd like them to complete, that you set up a meeting or you say, hey, can we jump on the phone real quick? Because this is just too much to type out. The same goes for AI and for large language models. There are a lot of times where we want to provide a lot of context, and this might be a back and forth conversation. And I don't want to type all this out. It's a lot of typing. So there are ways that we can go ahead and prompt with our voice. So I'm on a Mac. There is some dictation built in. So if you go to settings, keyboard dictation, you can set this up. You can set it up on your microphone with a particular shortcut. And this worked well for me for a while until I found out there are better ways to do it. And yes, some of these are paid ways, one of which is WhisperFlow. But what I found is that this is much better at dictation, and it formats everything so much better. And again, instead of having one long paragraph with no punctuation, this actually formats everything really well, and it just really helps out. So I want to show you an example of this today. So here we are on whisperflow.ai. I have this downloaded, but I'm going to go ahead and go over to ChatGPT. And now what I can do is, instead of typing out my query here, I'm going to go ahead and use WhisperFlow. I have a keyboard shortcut for it. You'll see I'm just going to hold that, and then we'll talk about creating maybe a simple Spring Boot application. Can you help me? I'm trying to create a new Spring Boot application, and I want you to act as a senior Java developer who has lots of experience with Spring, and I want to create a simple REST API that talks to some other service. Maybe the JSON placeholder service is a good example. And I want you to create a REST API that talks to this API using something like the REST client in Spring Boot 3.2. And at the end of the day, we're only going to have to call this once because that data doesn't change. So maybe we should add some caching onto this as well. So give me the steps for creating the application, how to implement the REST API, and then maybe how to add some caching to this. And if we go through here, you'll see All of that is formatted pretty well. Now, it's not going to be perfect, but I found it to be pretty accurate. And that is prompt engineering. A couple more things, and then we'll get into writing some code. And I think a good place to start here is why Java and AI? Well, now that we know a little bit more kind of the history of AI, right? Machine learning, deep learning, these neural networks, natural language processing, often AI has been associated with the Python programming language, and rightfully so. There are a lot of great tools and frameworks in this space for building out these large language models, for the things data scientists do on their day-to-day workflows. But I think we need to make a clear separation here. There is building these large language models and maybe fine-tuning them and giving them specializations. And then there is consuming these large language models. And so if we can separate that, now, if we are consuming the large language model, almost any language can do that, right? Some of these most of these large language models have a REST endpoint. We hit an endpoint, we ask it a query, we get a response back. So there is a distinction between kind of building the large language models and consuming them. And so Java actually is really well positioned to do this. We can leverage artificial intelligence in our Java applications. And why would we? Well, the world of software is experiencing widespread adoption of AI. Everywhere you go, you hear it. In fact, even within your own organization, and probably heard it too much at this point. Java is the language of enterprises. Something like 90% of the Fortune 500 companies run on Java. And so this is no longer a nice to have. This is a requirement. Spring AI provides API access for components for developer AI applications. I like to say this is a similar abstraction to Spring Data. We'll learn more about Spring AI in a second. There are a whole bunch of really great use cases, and part of this is kind of like learning these fundamentals and then going back to your team and like, what are some of the ways that we can leverage generative AI within our organization? Things like Q&A over private documentation, being able to summarize docs, being able to generate new text, code, image, audio, and even video these days. So when we talk about communicating with a large language model, we don't even need a programming language, right? I mean, well, you can consider Bash a language, I guess. But we can write a Bash script. So we are basically saying, here's my OpenAI API key. Here's my prompt. Tell me an interesting fact about Java. And then I can just run a curl command to OpenAI's completions endpoint. I'm passing the content type as a header. Here's my authorization with my token. And then I pass some data. I'm specifying a model, and then I'm saying, hey, I want to go ahead and ask this prompt. So once you do that, you'll get a response back that looks something like this. This is taken a little bit ago, so maybe it's a little bit older at this time. But the kind of structure is the same. The content you see in there in the middle of the screen, that is the response from the LLM. Then it also has things like usage, where it tells you the number of prompt tokens it took, the number of completion tokens, and what were the number total of tokens that were taken. We'll talk more about tokens in the next section so we can get an idea of what those are. We can also do this in Java. So here I'm using the JDK 11's HTTP client. I set up my API key. I'm using text blocks. So I have this nice formatted JSON. Again, tell me an interesting fact about Java. I send a request with that authorization header. I get a response back. The response would look pretty similar to the one we just saw before. So if we can just use curl and we can just use Java, why do we need some of these frameworks that are out there? And I think this is one of the points I want to hammer home today, is that Spring AI provides us so much more than a facility for making REST API calls. It turns out when you start integrating this into enterprise applications and building real-world applications, there are a bunch of problems that you're going to have to solve for. You can certainly solve for them yourself if you'd like, but as you'll see throughout this course, Spring AI really does a good job at solving these problems in an elegant fashion, making it easy for us allowing us to kind of focus on the task at hand, not a lot of the infrastructure that it takes to do some of the things we're going to solve for. So one slide on Spring AI, and then we'll get into this. So I like to say Spring AI is AI for Spring developers. It's also AI for Java developers. The same way Spring got me as a Java developer into enterprise development, I think Spring AI is going to get a whole bunch of new folks into AI development. You can learn more at spring.io/projects/spring-AI. This was started by the great Dr. Mark Pollock. The current version is 1.0.0. And there are a lot of like really key features that Spring AI gives to us. One of the most important ones, I think, is the portable API support across all the AI providers for chat, image, audio, and possibly one day soon, video, right? So there are so many models out there. There are so many models within each of these companies, right? If you go look at OpenAI, they'll tell you, here are all the different models we have. How do you choose one? We'll talk about that today as well. But the one thing that you don't want to do is write code to a specific model, because as we know, if you pay attention to the news, every week a new model comes out. It has the best benchmarks. It's the newest, greatest model ever, followed up by next week when we get the newest, greatest model that week. So what we want to do is we want to write code to an interface, to an idea, to an abstraction, not to a specific model. So that if we want to swap out the model from a configuration standpoint, we can do so without changing the code across our entire code base. So that's very big for me. We also have synchronous and streaming options, which we'll look at today. And Mark always says that this was inspired by Python projects like LangChain and Llama Index. Okay, so I think that's all we have in this section. Next up, we're going to get started by getting an API key and writing some code together. All right, so enough kind of overview stuff. Let's get into actually writing some code. Let's talk about what we need to do to get started with that. So we're going to have to sign up for an API key. This could be OpenAI. This could be Google Gemini. This could be Anthropic's Claude. Whatever one you want to use. I'm going to use OpenAI today. We'll also use Claude to like configure multiple LLMs. But you'll need an API key if you want to follow along. You do have to put some money into this account. I've put $5 or $10 into the API account. Haven't used it because I'm just using it for little demos like this. So you don't have to put a ton in. But I wanted to put that out there. Now, you will want to set up an environment variable for this. You don't want to just hard code your API keys into your application. So having an environment variable for this is good. From there, we'll go to start.spring.io. We'll create our first AI application using Spring AI. And from there, we'll look at some of the basic building blocks. We'll look at the chat client and the chat model. We'll do this in both a blocking and a non-blocking fashion. We'll look at some of the response types that we can get from the model. So some of them have all of that metadata. Some of them just have that response. And then finally, I'll show you how to use multiple models in a same application, because when we just use one, everything gets auto-configured for us and everything looks great and so easy to use. When we want to use two, we got to configure some things so we can tell it like, hey, in this, maybe this REST controller, we're using the OpenAI model. In this REST controller, we're using the Anthropic Claude model. So that's my plan for this. Before we do that, I want to talk about pricing because it's important. I don't want you to just run off and start using this and then come yell at me in 30 days saying, oh my gosh, my bill is so expensive. To do this, when it comes to large language models, there are two different kind of pricing buckets, if you will. The first is from the consumer side. So if you go to ChatGPT, you can see some pricing for ChatGPT here, free to use for the free tier. There are some limitations on that, $0 a month. Here's what you get. For the Plus plan, you pay $20 a month. You get a little bit more. And then on the Pro plan, $200 a month, you get a lot of things. This is for the consumer side of things. So as a consumer of ChatGPT, the product, not the models themselves, the product that sits on top of that. This is the pricing for that. It's much different for API use, which we are going to use in our applications. So this is just an example of OpenAI's pricing page. If you go to any of these large language models, there'll be a pricing page, and they'll look similar to this, different pricing. The pricing is based on 1 million tokens. What is the token? We'll get to that in a second. So the input is $2 for 1 million tokens in, and then $8 for 1 million tokens out. So in is what I'm sending it, out is the response from the large language model. And so this is important to understand. So what is a token? So we have this thing called a context window. And the context window, think of it more from a vertical standpoint. If you go to ChatGPT and you type in a prompt, that is going to be what's known as the user message. There are all kinds of messages that can basically add to the context window. So the user message is what I typed in. When the LLM responds, that's the assistant message or the response. And that is now added to the context window. And as we're having a conversation, all these messages get added to the context window in the form of a token. So we'll see what a token is in a second, but in the form of a token. And so the context window sizes matter. There are certain fixed sizes. You can only add so much to the context window, and that becomes important. Now I want to look at an example. OpenAI actually has this thing called a tokenizer, and we'll see how tokens kind of play into this. All right, so here I am on openai.com. I'm going to type in some prompt here. Tell me an interesting fact about Java. So I'm going to copy that, and then I'm going to go ahead and ask that question, right? So here's an interesting fact. Now, OpenAI has this tokenizer. So I can go in and I can paste some text and I can say I'm using this particular model. And what we can see down here is that this text is roughly 7 tokens or 38 characters, but all we care about is tokens. And if you remember from earlier, I can go ahead and look at the token IDs for this. This is how it's broken it down into pieces. Here are the IDs for those tokens. Here's the text. Now, it's not always a word to token translation. In fact, in here you can see it's not. But what it says here is this translates to roughly 3/4 of a word. So 100 tokens is roughly 75 words, right? So this is a really good way of visualizing it. But again, now the responses come back. I got to add that to this. And now we see that we are a whole bunch more tokens. We're at 153 tokens. And as I start having this conversation, the context window starts to expand. Okay, so that's the context window. Now, why I bring this up is because if you look at the pricing for all of the different like kind of frontier models out there, this is just a short list, but you'll see the model, the context window, the number of tokens we can put into a window at one time, and then the pricing for those. And now pricing matters, folks, right? If we are going to if we're just doing something silly on our machine and it's not taking throughput, doesn't matter. When we take this and put this into production and it takes high throughput, this chart is going to matter. If you look down in the middle, GPT 4.5 preview, $75 for 1 million tokens in, $150 for 1 million tokens out. I know we just had that little example, but these million tokens will add up quick in these high throughput applications. So this is really big. If you look down at something like Google Flash, 10 cents per million in, 40 cents per million out. Huge difference, right? So this is one of the things you kind of got to ask yourself when evaluating models. Speaking of, I mentioned it, there's all these models out there for all these different platforms. And it seems like every week we get the new latest and greatest model, right? So how do you evaluate which model to use in your application? Well, some of this is going to be through trial and error. You're going to have to try different models. Don't just pick one and say, this is what we're using unless you've done your research, you know. Try different models for your specific use case and see what works for you. If you go to the Spring AI reference documentation, you'll see under the chat models, which models are supported. There is a growing list that's changing all the time, but all of the major models that you would expect to see there are there. And then things like Ollama, which allows you to bring in open source models. So you go to ChatGPT and you see, oh, the latest models. Here's our latest models, our reasoning models. Now we also have these specialized models for image, audio, and video generation. And if you go to any of the big kind of frontier models, you'll see the same. So now the question becomes, oh my gosh, which one do I choose for this specific application that I'm working on? So you go check out some benchmarks. And based on the benchmarks, every model looks like it's the greatest model ever made, right? I mean, most of the numbers are pretty close to each other. So then maybe pricing becomes a criteria. But I have some things here to kind of guide you through this. And this is something that you can use to like kind of pick a model. So task fit, does the model already solve your task? Like, can it generate code? Can it generate Q&A over documentations? Have you seen evidence of this or similar domains? Quality and benchmarks. Look at the benchmarks. Are the recent third-party numbers on tasks that resemble yours? Maybe the vendors cherry-picked them. But just, I like the benchmark as a gauge, not an end-all be-all. I don't just sit here and like stare at these benchmarks and say, this is the only thing I'm going to use to determine what I'm using. It's just another data point in your decision making, right? Context window. Is there a hard cutoff? Anything below that needle, that context window, then you can disqualify those models. Latency and throughput. Are we user facing? Are we doing batch background? Is this real? Does it support real-time streaming? Cost, probably a big issue. It is for me. My friend Deshaun always says he doesn't have cloud money. He has Raspberry Pi money. So he runs a lot of models locally. And I get that. So if cost is going to be a big thing, you don't want to pay $150 a token or per million tokens, you got to take this into the consideration, right? Privacy and data. Can the data leave your VPC, right? Your network? Do you have data that you don't want to share with the frontier models? Do you have personal information, personal identifiable information about customers or employees? Do you have trade secrets? You don't want to train the models on this data. If no cloud, then you have a short list of local open source models that you can choose from. Integration and tooling. When we get into like what are some of the the limitations of large language models, we'll look at something called function and tool calling. If that is important in getting up-to-date events and real-time information, make sure the model supports tool calling. And then governance and support. Do you have SLAs, rate limit ceilings, security postures, and audits? This is something else. So these are all the criteria. Don't just pick a model. I mean, you can just pick a model and run. But if you really want to start to evaluate models, here's some criteria that you can take a look at. And then I have this kind of workflow. Define the job, not the model. Write a one-line job description for the LM. Anything that doesn't satisfy that job is out. Shortlist 3 to 5 candidates. Run a 30-minute smoke test. Automate a narrow evaluation. Use LM eval harness or OpenAI evals. We also have a way to do some evaluations here in Spring AI. From that, weigh the metrics, score each of them, prototype and monitor, get the winner in there. And again, we'll see an example of this, but there may be situations where you need multiple models. Maybe this one is very good at this use case on this side of the application, but on the other side, we're doing this other thing, and maybe another model works better for that. So this is part of kind of evaluating models. To get started, don't worry about it. Just use OpenAI with me. I use a bunch of different models, but this is an easy way to get up and running, but you can use any model you want. With that, let's go get our API key. Let's create a new project at start.spring.io, and let's write some code together. All right, to get started, head over to openai.com. I'm going to go over to this login, and I want to log into not ChatGPT. Again, I am a paying member for ChatGPT. I have the Pro plan, or whatever the $20 a month plan, not the $200 one. So I can log into ChatGPT here and kind of get all that history, but I want to log into the API platform. And this is platform.openai.com. In here, you'll find a lot of stuff in here for like learning, documentation. We have some pricing, some libraries, some tools. building agents, real-time API, model optimizations, specialized models, OpenAI platform, codecs, best practices, a whole lot of stuff in here, right? What we care about is up here. If we go to our profile, you'll see a whole bunch of settings in here. And one of these that you'll see is API keys. So we go into here, and as the owner of this organization, you can view and manage all API keys. I believe my current ones are underneath my the old way of doing it. But what we want to do is create a new secret AI key. So let's call this AI for Java developers. We'll put this under a project. Default project is fine. And we're going to have all permissions. So we're going to go ahead and create that secret key. And once that is done, I can go ahead and copy this. So I will delete this key before you see this video, just in case anyone has thoughts of taking this key and having fun with it. It'll be gone. But I copy that. And now that I have a key, I could go ahead and hard code this into the application, which I will show you how to do. But another thing you can do is set an environment variable. So why don't I just ask my good buddy here, ChatGPT, we'll say 4.0, how do I set an environment variable for Mac and Windows? I'm doing this because it's been 15 years since I've used Windows. I know you can like export the path, but from a Mac OS standpoint, I just go into Bash, in my case, a terminal, and I can go into my ZSH configuration and export a particular variable. I say something like export open AI API key is equal to, and then that, and that would go ahead and export it out. I don't know what's going on here, but it doesn't matter. The point is you want to export this as an environment variable so that you can use it in multiple projects and not just one. All right, once we have that, we can go over to start.spring.io and create a new project. So I'm going to use Java Maven, the latest version, which at the time of this recording is 3.5.0. And I'm going to say dev Dan Vega AI Java devs. Actually, let's call this Spring AI Workshop. And then I'm going to choose JDK 24, and I don't need this as a package. Let's just call this workshop. All right, so then we're going to add some dependencies. So I'm going to build a web app. So that's the first dependency I need. And then the other dependency is what model am I going to use? So if I start typing AI, you'll see a bunch come up. So we have Azure, Mistral AI, Stability, Anthropic Claude, Amazon Bedrock, OpenAI, Vertex, a whole bunch of things here, right? For my case, I'm going to choose OpenAI. And then we'll go ahead and generate this project. It is going to download a zip file, and then we'll go ahead and open this up in whatever IDE or text editor you're most productive in. Again, for me, that is going to be IntelliJ Ultimate Edition, but you can feel free to use whatever IDE you want. All right, so I actually renamed this to Java AI Workshop just because I had Spring AI Workshop already there, which is the main repo for everything that we're going to do. So I just wanted to refactor that. And I'm just in that same vein, I'm going to say this is workshop. Okay. Yes, refactor. Okay. So now what we can do is we can start to build out our application. So looking at the POM, we have our Spring Boot Starter Web. That is our main dependency. And then whatever model we pick is going to start with Spring AI Starter Model. And then this will be OpenAI. There's one for Anthropic. There's one for Gemini, etc. So that is what those dependencies will look like. But that's the only dependency we need to get up and running. Now we need to configure the model. So we know that we're going to use OpenAI, but as I said, OpenAI has a bunch of different models. We can choose from a whole list of models. But based on what we're doing, we'll have to select a specific model. And then we also need to configure our API key here. So I'm going to say spring.ai OpenAI API key is equal to. Again, I could come in here and hard code this value, and you could do that if you want to just get started. Please don't check that in. But what I'm going to do is use an environment variable that I exported. You can also, once you run this application, you can come up here and edit in IntelliJ and add this as an environment variable there. There are a bunch of ways that you can do this, but I like just exporting this at the OS level. So now I can, whatever application I start, this environment variable has my API key in it, all right? So that's good to go. Now we need a model. So chat options model, and I'm going to choose GPT-4o. So that is our model that we're going to work with. So this is great. These are the two things that I make sure I set every time. There's a bunch of other things you can configure, but not to get up and running. Some things like, and again, this is where looking at the Spring AI reference docs will help. But we can come in here and say something like OpenAI. Let's say we wanted to set the max tokens. So remember, we said tokens kind of fill up that context window. Even if we had something like Gemini that supported 1 million tokens in the context window, we may not want to allow our users to stuff 1 million tokens in every context window, right? That's going to get very costly for us. So we can set some max tokens here. And again, there are a bunch of things. So if we just go off of here and we say dot, there are a bunch of things that we can go ahead and configure here if we need to. And again, use the reference docs to see what else you can go ahead and configure there. But this is all we need to get up and running. So with that, let me keep this kind of with the final structure. I'm going to go ahead and create a package here. I'll call this chat, and we'll go ahead and create a new Java class. I'm going to call this just my chat controller, and this will be a class. So we're going to create a REST controller so that we can hit an endpoint, and then from that endpoint, we'll take some action to call an LLM, give it a prompt, and get a response back. Okay, so let's start with the chat client. We need a chat client. So let's say private final chat client, chat client. Now this is the interface. So the interface is a chat client. So we need an implementation of that. If you look in here, there's a way to use the chat client's create method. It is a static method. So you could say chat client.create, pass it a model. Maybe you want some observation in there. There's also these builders. So we have some builders saying, hey, go ahead and create it from a chat model. What is a builder? A builder is another interface. And if we look over here, we can head to the default chat client builder, which implements chat client.builder. And this is something that gets created for us when there's only one option on the class path. So when we look at kind of configuring multiple LLMs, that will be a little bit different. But when there's only one instance, which there is, we'll get this default chat client builder for us. So that means if I use constructor injection, what I actually want to get is an instance of chat client.builder. We'll call this builder. So again, Spring is going to wire that up for us. And I'll say builder.build. And now I have an instance of the chat client. This is what I need to talk to the large language model. So let's do this again. Let's go ahead and say we're going to return a string. We'll call this chat. We could take in a message, but we'll just hard code one for now. And then what we'll do is we'll use that chat client. We can pass it a prompt. We could pass in a prompt here, or we can use the different types of messages. So there is a user prompt, remember. There is a system prompt. There is a tools prompt. Like there are a whole bunch of different types of messages that we can send. So for our case, I just want to create a user message, and this will be the prompt that I'm sending to the LLM. So tell me an interesting fact about Java, right? So then what we need to do, now that we've given it a prompt, our next decision is, do we want this to be a blocking call or a non-blocking call? in this case, it's pretty easy. I just want to use a blocking call. And then our last choice here is, what do we want the response to look like? Remember, there was a whole bunch of metadata that came back from the API call that included like what model we were calling, the tokens, like how many completion tokens and prompt tokens. And in the middle of that, there was the content, which is basically the string response from the LLM. In this case, that's all I want. I want the string content back. So this is all we need to do. Now we need an endpoint for this. So I'll say get mapping /chat. And this is the only code we need to talk to the LLM, get a response back, and then we can just, because this is a REST endpoint, we can display this to the user. So let's try and run our application. So I'm going to run our app here. Everything looks like it's good. Now what I need to do is use some type of client to hit this endpoint. You could use whatever tools that you like. You can open a terminal, you can use something like Postman, or there's a ton of really good clients out there. IntelliJ actually has a client built in, but what I'm going to do is just go ahead and open up the terminal and use a utility called HTTPie, which is kind of like curl, but I never remember commands in curl, so I might say HTTP, which is basically just a GET request to localhost 8080 /chat. And hopefully what we are doing is asking LLM, which is OpenAI's GPT-4o, to tell me an interesting fact about Java. And it was originally designed for interactive televisions. I actually knew that. So cool little interesting fact about Java, and we just got the string response back. Okay, so this is good. But one of the calls that we made here is a blocking call. What if we were asking for a larger response back? One of the examples I like to give is like, hey, I'm visiting Las Vegas soon, or visiting Kansas City soon. Can you tell me 5 places or 10 places in Kansas City that I must visit? Actually, let's use Hilton Head because I'm going on vacation to Hilton Head soon. That would be a much larger response. And if we had some kind of chat interface, it would not be a good user experience for the user to type in that prompt and wait for the entire response to come back. That would not be fun. I want to start streaming the response back to the user as soon as possible. So let's have another get mapping. We'll do this to /stream. And let's just say public. Now string is not the return type, but we'll talk about that. And what I want to say is return chat client dot prompt. And then I think, are these coming from Copilot? Are these coming from Rinser? I'll find a way to turn these off because some of them are wrong, and they're kind of annoying when I'm trying to show things off. So, okay. So we still need a user message. So we're going to type in, I'm visiting Hilton Head soon. Can you give me 10 places I must visit? Okay. So now instead of calling .call, which is a blocking call, I'm going to call stream. Again, I just want the content out of it, but we're going to get some complaining here because it's not going to return a string. It's going to return a flux of strings. And this is from Spring Web Flux, Project Reactor. We are bringing that in as a dependency so that you can use streaming as an option. And so when you do that, you're going to get a flux of strings back. So now let's go ahead and rerun this application. And I'll go over to the terminal and let's just clear this up. And so I'm going to say HTTP. I'm going to tell my command line utility that I expect a streaming response back. And I'm going to say stream. And from that, it's going to start giving me those responses as they come back. So I don't have to wait for the entire response to come back at once. So that's pretty cool. So there, right out of the box, we've written a simple chat command to talk to OpenAI's GPT-4o. We also looked at the streaming response. I want to look at one more. So public, let's say string chat. Let's call this a joke. All right. And what I want to return from here is something different. Let's say, tell me a dad joke about dogs. And I'm going to make a call, blocking call. Now, instead of getting the content back, which is the string, I want to get something called a chat response back. So now let's go ahead and change this to chat response. And if we look at the chat response, go ahead and download these sources. The chat completion generation response returned by an AI provider. So again, this is the chat response. And depending on the model that we're talking to, the response might be a little bit different. So let's go ahead and rerun this. And again, we'll go back to the terminal, clear this, HTTP 8080/joke. Did we not put an endpoint on that? We did. Oh, we did not. Okay. Yes, that's what we need. Thank you. Maybe I will leave those completions on. Okay, so let's try this again. So now we get all that metadata back that we saw earlier, right? So here's metadata. Here's the model we're using, GPT-4o. Here's the specific one that we're using. We get some rate limiting on this. What are the usage? Here's the completion tokens. So we see prompt tokens are 14, total tokens are 34. That's good information to know. The results, here's the output. Here's the text. Why didn't the dog sit in the shade? Why did the dog sit in the shade? Because he didn't want to be a hot dog. Love it. So if you ever want to get back more information about the response, that's one way you can do so. Now, again, we've configured OpenAI because of that starter, right? So if we look at pom.xml, we have this OpenAI Spring AI starter model, OpenAI. What if we had a second one? So what if we came in here and said Anthropic, and we explore this and we see what starter we get? We will get another starter here, right? So now if we go back over here and stop this, we're going to need to do a couple of things. First, we are going to turn off auto configuration for that default chat client because it's not going to be able to do that for us. It's not going to be able to do that because there are now two possible chat models on the class path, and it doesn't know how to pick between them. All right, so we can fix this pretty quickly. We can come in here and say Spring AI chat client enabled equals false. So now we have, this is open, let's just do this right, open AI config. And then we will need to configure Anthropic Claude config. So we'll say spring.ai.anthropic API key. That looks good. And then I'll just leave the default model on here. Actually, let's just do this. Anthropic chat model. I believe this would be Sonnet 3.7. So if you're ever unsure, you can always pop over to Anthropic's website in this case and look at the different model names. So you can see the Anthropic API. I want to use Claude Sonnet 4 actually. So let's go ahead and select that. And then I'll just go ahead and paste that in there. Okay, so now we have two models configured. So when we go into, say, our chat controller, it's going to go, well, first of all, there's no builder because we did not, we turned that off. We don't have an auto-configured default chat client for this. So let's just say this chat client, actually, let's back up. Let's configure both beans and then we'll come back to this one. So what I want to do in a configuration class somewhere, I'd probably put this somewhere else, but for now, this is fine because I'm actually going to back this out. Once we take a look at this demo, I'm going to back this out and just stick with OpenAI. I just thought I'd show you how this works. So I have a couple of beans here. So let's do this AI Anthropic. So what I'm doing is I'm setting up a couple of beans. I'm creating a chat client called the OpenAI chat client. So this takes in the OpenAI chat model, and then we use that static create method to pass in the chat model. Now, because these are on the class paths, we have a chat model available to us. So I'm just creating two different beans now. I'm saying this is OpenAI, this is Anthropic. So let's say for the chat controller that I wanted to make sure that this particular chat client is the OpenAI one. So first thing, we don't need a builder now because we've created chat client beans, right? So I can just call this a chat client. And this is already going to be there. So I would just say chat client. And so now what I can do is I can say I have a qualifier for this. And the qualifier is the OpenAI chat client. That's the one I want you to use in here. Then I can go ahead and create a new Java class. Let's just call this the Anthropic chat controller. And we'll do something similar. You create a REST controller. I have a chat client live template here, but that's not going to work. Let's go ahead and say chat client. And then I would need to put a qualifier on this as well. And maybe we'd call this the Anthropic chat client. So now this scales out to as many as you want. I don't know that you'd want 10 different models in your application, but there are definitely scenarios where you could have multiple models. And we just configured the beans for that. So I have an OpenAI chat client, an Anthropic chat client, and wherever in your application you want to use it, you just ask for a chat client, and then you can set this qualifier. So again, kind of backing up to the chat controller without a qualifier. The big thing here is we're writing code to the chat client, which is an interface. The builder is an interface. We're writing abstract code here that is not tied to a specific model. We can configure the beans underneath the hood in this case because there's multiple ones. We could just configure the model in our application.properties and all of our code stays the same. We can just switch out configuration code and our main code stays the same. And this for me is really, really important, especially with all these different models coming out. So I wanted to show that off, but what I'm going to do is I'm going to back this out because I don't want to kind of confuse this going forward. There's an example in the final repo that points basically to another repo that shows this off, but I want to keep this pretty simple as we go forward. So there's a, let's move this now. We don't need a qualifier. We'll have to go back to our builder. Right. So all this should work the same now. Let's remove those. Cool. So now we're just kind of left with that. All right, so that is my getting started. We were able to set up an API key over on OpenAI. Again, you can use whatever model you want to use. We were able to create a new project using the Spring Initializer, picking our model provider of choice. We were able to create a simple chat endpoint here that talks to the large language model. We get a string response back. We also looked at being able to stream responses back. This is good for chat interfaces where we don't want the user to have to wait. And then I showed you an example of a different response type here, which is a chat response. Later in the course, you'll see there's another type of response we can get back, which is of type entity, or the name of the method is actually called entity. So we'll look at that as well. So that's my getting started. In the next section, we'll take a look at more features of Spring AI that really helps you when you're starting to build out some of these real world applications. All right, so we saw how easy it was to get up and running with Spring AI. And now I want to dive into some of the features that really get me excited. So we're going to talk about a few things here today. We're going to cover the reference documentation. I just want to dive in and kind of show you around and show you where to find things when you're in there, because we certainly cannot cover everything in Spring AI in this course. So that is a really good reference to go to and find some answers to your questions. We'll start off with prompts and prompt templates. We've seen that already. We saw a user message. We can type in a user message. There are other messages like system message. There are some reasons to use a system message. There's also a different way to pass in a user message when we maybe want to use prompt templates. So we'll take a look at that. Structure at output becomes very important. And this is one of the other big features of Spring AI. So we'll talk about what it is using a pretty good example outside of Spring AI. We'll look at why it's important, and then we'll see how to implement that in Spring AI. Spring AI has multimodality support. So we've been talking a lot about text, but we can support images, we can support audio, and probably at some point video. But we can use this to generate some images or read an image and ask it for information about that. Finally, we'll take a look at chat memory. One of the things that we have to remember is the web is kind of stateless. So when we're using a product like ChatGPT, that is a product that is talking to the models. That product is the one remembering the conversational state. And so how do you do that when you're just working with the API? So we'll take a look at some features in Spring AI to help us with that. With that, let's check out my demo. Let's go ahead and write some code together. All right, so I think a really good place to start is the Spring AI reference documentation. I mentioned it a few times, but it's a really great resource to kind of dig into some of the things we're not going to cover and dig a little bit deeper into some of the things we do cover. So nice introduction, a lot of talk about some of the major features of the framework. And again, we'll get into some of those. Some AI concepts here if you want to learn more about like models and prompts and prompt templates and embeddings. Some really great information here. What I want to dive into is the reference. So if you look at the reference, one of the things you'll find is the chat client API. And if you dig into models, you can find out what chat models are available. Here's all the different chat models that are available. And there's also this nice chat models comparison. So this table compares various chat models supported by Spring AI, detailing their capabilities. So as another resource, when you're trying to determine what model you want to use for your next project, this will be another good resource that you can have. It kind of tells you everything that it supports. So that's a great reference. Now you can also talk about or find out more about some of the features like prompts, structured output, multimodality, chat memory. These should look familiar because these are some of the things we're going to cover in this section. Now, if you look at prompts, let's go into prompts. There's some information about prompts. There's actually a prompt type in the system, so which implements something called a model request. And if you dig a little bit further, there's a message interface that encapsulates a prompt's textual content. And there's this really nice diagram down here that kind of shows you the different types in the system. So when we talk about working with a large language model, remember I said there's those different types of messages we can send. So our message or our prompt that we send is called a user message. There's a system message, which we're going to look at, assistant and tool. And you can see how this kind of fits into Spring AI. So there's these things called roles, but what I want to focus in first is prompt templates. So a key component for prompt templating in Spring AI is the prompt template class. Designed to facilitate the creation of structured prompts that are then sent to the AI model for processing. So we're going to use this both in like templates and structured prompts, sorry. This class uses the template render API. By default, we use the string template renderer, which is based on the open source string template engine developed by Terence Parr. The other thing with this is you'll see you can go out there and look for prompt templates, and a lot of them use this string template engine. So if you want to like copy a template from someone else, you should be able to. But templates are identified by these little bracket syntax. So that's how it is by default. You can always override that. So you can create your own kind of template renderer. So in this case, you see we use like a start delimiter as the greater or the less than sign, and then the end delimiter is the greater than sign. What we're trying to do here is we want to provide some text, but we want to have some variables in there. So we want to replace composer with the actual composer that we want at runtime, right? So we may take this in as a path variable or a request parameter, and then in our endpoint, and then when we call the large language model, we want that replaced with whatever was kind of passed in. So that is a prompt template. And then if you dig further, I think you can see there's some example usages of this, but we're going to go through this. So really great resource to kind of get started with here in the Spring reference documentation. So let's do a few things here. Let's go ahead and create a new package. Let's call this prompt. And I think we should do this a couple different ways. I want to start with, let's say, the Acme Bank controller, right? So let's say we have a REST controller. Maybe we have a request mapping of just Acme, right? And let's get a chat client. So I have a little shortcut for this. This will create a chat client. And now we need a method to maybe just chat. So maybe we have a request method of, get mapping of /chat. And we want to do a couple of things here. So we're going to get back a string. We'll call this chat. And sure, but let's change this up. Let's go ahead and take in a chat. So I'm going to get a request parameter. We'll call this message, and then we'll take this in as the user message, right? Okay, so what we want to do here is, this is Acme Bank. This is the Acme Bank controller. And I want to show what the problem is here and how we can fix it. So let's go ahead and run this application. So again, /acme/chat, that's our endpoint. Did we not get rid of everything? Yeah. So I don't think we got rid of this yet. So let's do this. And we refresh that. And then our properties. Yes, that should be good. Let's see if we can run this now. Okay. So now we can go back over to the terminal and we can make a call to HTTP localhost 8080/acme/chat, and we can pass in a message, and we could just pass in any message at this point, right? We can ask Acme Bank about anything. What are the top 5 NBA teams of all time, right? So I've been watching the NBA finals. This is why a couple of these examples will be in around the NBA. If you're outside the US and not familiar with the NBA, it's just our National Basketball Association. So I'm basically asking it, what are the top 5 NBA teams of all time? And we got a response. Maybe not in line with what you think, but this is a response. The problem with this is Acme Bank Controller should not be responding to questions about the NBA, right? Like, we should have some guards on this to basically say, I don't want you to respond to anything like that, okay? So what we're going to do, and I'm going to save some time here and copy and paste some text, we're going to say, we're going to create a new type of message. So we know that we have this user message. And so I'm going to copy some text and we're going to paste some in here. And this is our system instruction, right? So what we are saying here is UI Customer Service Assistant for Acme Bank. You can only discuss account balances, branch locations, general banking services. If you're asked about anything else, please respond with, I can only help with banking related questions. And again, this is helping us put some guardrail on our system so that we don't have any type of just generic chat, right? So now when I ask that same question, we should get back a response of like, hey, I can't talk about that. Although it seems to be thinking, so I don't know if I saved this. Let's take a look at this. I don't think I saved it. So, oh, we missed a step. Okay, so we pass in our user message. We can also pass in a system message. So this says, hey, this is my system message. You could also do this. This is something we haven't discussed yet. But when you create a chat client, you can set some defaults. So maybe I wanted to set a default system message so that any method in this particular controller uses those same system messages, right? We're not going to do that. We're going to set this here at the system level. So now once I do that, I can go ahead and stop and rerun this. And hopefully we can go ahead and try to run this again and see if this works this time. So now what are the top 5 NBA teams of all time? Sorry, I can only help with banking related questions. Okay, so this is a good start. This is one reason that we can use the system message to put some guardrails on any user message that comes in. So any user message that comes in here, we have some guardrails kind of guarded by the system message. All right, so that's one example of why you would use a system message. Let's look at another one. So here in the prompt package, I'm going to create an article controller. Let's say new Java class article controller. Okay, this is going to be, let me just double check my notes here. Yes, that's what we're going to do. Okay, so what I want to do is I'm going to create a REST controller. We're going to get a chat client again. This is going to look pretty familiar, but if you want to like follow along and pause, get those reps in and you kind of get used to it. So I want to create a Git mapping to /posts/new, and this is going to be to create a new article here in our system. So I'm going to say public string new post, and we're going to take in a request parameter. So request param, and the value for this is going to be the topic, right? So what is the topic? And we'll set a default value in case one is not set. So we'll say JDK virtual threads, right? And we will call this the topic, okay? So now that we're in here, let's go ahead and I'm going to copy in my system message for this. So as I mentioned before, we saw one reason to use a system message. Let's look at another reason. What we want to do is like set the overall context for what this chat is supposed to do, what this interaction with the LLM is supposed to do. So here I'm taking a topic. This could be any topic. But what I want to do is I want to write an article about this topic. I think I mentioned this before. I did. And if I went up to you and said, write an article about JDK virtual threads, you probably have a lot of questions. How long should it be? Who's the audience? What's the tone and style? I don't want the user to have to type that in every time. So what I can do is if this endpoint is specifically for writing articles, I can set the overall context. I can say blog post general guidelines are this. Here's the length and purpose. Here's the structure I want. Here's the content requirements. Here's the tone and style. Here's the response format. This is good. This isn't great. You could probably even do a little bit better than this. In fact, you can, but this is a good start. So now that I have some guidelines, let's go ahead and take a look at a couple of things. I want to take a look at prompt templates, and I want to take a look at adding this system message for the overall context. So again, I'm going to use the chat client. I'm going to say prompt. I'm going to pass in a user message, but I'm not just going to pass in a message of write me a blog post, because I want to say write me a blog post about the topic. And so the topic is something that we will have to add as like a variable, placeholder that gets replaced by the user's topic. As we can see, we can add text, we can add a resource. We can also pass in this thing called a consumer, which is a prompt user spec. So if we look at that, what we'll find out is that this prompt user spec is an interface. So we have this prompt user spec, but it is also a consumer, which is why we can go ahead and pass this in as a Lambda expression. So what I can do now is I can say, Okay, u.text. What I want to do is write me a blog post about, and now I can pass this in as a string template. So I could say topic, right? And then I can say u.params, or just param in this case, which is going to be topic. And then that gets passed in as an argument to this method. So what I can say there is I'm setting the user message, but I'm passing in text and I'm replacing that string template with that. I can also say, hey, what is my system message? So there's my system message. I can say, go ahead and make a blocking call. And I can go ahead and say, what I want back from this is just the string content. So again, we can test this out. I'm going to rerun this. And let's say it looks like it ran. Let's go ahead and hit an endpoint. So we are at /post/new. So HTTP 8080/post/new. Oh, we got to send in a topic. So let's, dogs seems like a good topic to me. Let's say dogs. And then I'll go ahead and hit enter. And hopefully what we did get out of this is now we get a 500-word blog post with this structure, an introduction, a body, and conclusion, and then some requirements. And here's the tone and style. When it's done, here's what we got. So we can see we get that title, we get an introduction, we get 3 sections, and then we get a conclusion. So this is really great. So just to recap, we took a look at the system message for a couple different reasons. One, to put some kind of guardrails on or restrictions on what kind of prompts we can accept from the user. The second is to give us this overall kind of tone or overall context to what we're doing. This way we don't need to repeat this every single time that we call this method. And then we saw that the user method here method was able to take both the string text and a prompt user spec, which in the prompt user spec, we have things like text and params and media. But what this specifically allowed us to do is use a string template here inside of our user message. So now we can replace that with an actual topic at runtime. All right, so the next feature of Spring AI that we're going to cover is called structured output. And if you are in the reference documentation, you can go to reference and structured output to learn a little bit more. There were some older ways of doing this that have since been deprecated. But the ability of LLMs to produce structured output is important for downstream applications that rely on reliably parsing output values. Developers want to quickly turn results from the AI model, such as like a string response, into data types, such as JSON, XML, or Java classes that can be passed to other application functions and methods. So I'll leave you with that. Here's kind of the structured output converter before we take a raw input from the user. We provide some formatting instructions. So we have their input plus our format instructions. We make our call to the LLM. We get our raw output text. We convert that text to a structured output, and then we get that structured output. So the documentation here, there's a lot you can go through and kind of learn a little bit more, but I'll just kind of show you how I think about this. So when you go to an LLM, and you're going to type in some query. So I'm watching the NBA finals right now. I'm going to use this as my example today. So if I say, what are all of the teams in the NBA? And I'm going to ask this question from a chat interface. I really don't care about the output, right? I'm more concerned about the quality of the output. Like, what is the answer? So this could come back many different ways every time I ask it. It could simply list out alphabetically all of the teams. So starting probably with the Atlanta Hawks, and then it can go all the way down and list those out. It could also list them out by conference. It could list them by conference and division. The point here is, like, I don't really care how it does it. I haven't told it that I need it in a specific output. I'm just looking for an answer. So when we do this, we should get it some different way. So here it is by conference and by division and the team name, right? So I don't care about this. But when I'm working in an application and I'm working, say, with types, I want to have a type of maybe all the teams, and a team has a name and maybe the city it plays in. So I need this information. I need it every single time because I want that JSON back. I want to like turn that into a type in my application. So we need to be very specific about it. So here I am in AI Studio. This is kind of Google's playground. You can do this over on OpenAI as well as with Anthropic. But usually in the backend playground, these are more for developers. You can kind of tweak some knobs. And one of those knobs here on the right is structured output. So again, if I ask this same question, what are all the teams in the NBA over here, I'm going to get a similar result. But what I want to be sure of is that I get the exact same result every single time. So we can do this with structured output. So I can turn this on and I can say edit. I can use the code editor to like type out code, or I can use this nice visual editor. And so I'm going to say that I want back an object, array of objects called teams. And inside of there, I want the name, which is a string, and I want the city that the team plays in, right? So just by providing this structured output, now when I go ahead and ask this question, we should get the result that we are looking for. Now we know what it's going to come back as a particular, in this case, a set of a JSON array with each object inside having a name and a city that it plays in. So when it comes back that way, and I know it's going to come back that way, then we can use that in our application. We can deserialize that into a type, right? So that's pretty cool. Now the trick here is Google and OpenAI and Anthropic and all the other models out there, they kind of handle structured output differently. So we have to kind of do that behind the scenes. And the nice thing is Spring will do this for us. So what I want to do is jump back over to our application here. And I want to kind of lay out a example of this. So let's put this in a package called output. And in here, we're going to create a new Java class, and I'm going to call this my vacation plan. All right, so this is going to be a REST controller, and inside the vacation plan, we'll need a check client again. Now, I'm doing this kind of every single time. If this was the same, I would put this check client in a configuration file somewhere, and then I can just use it anywhere in my app. But just for simplicity's sake, I'm kind of doing this over and over again so we kind of get the reps. So I need a chat client, right? So then I might create a Git mapping, and let's call this vacation unstructured, right? So we have vacation unstructured. So we're going to get a string back. We'll call this unstructured. And so what we'll do is we'll return the chat client dot prompt and dot user. Sure, I want to plan a trip to Hawaii. Give me a list of things to do. So we'll go ahead and call that. Oops, no, call. And then content, right? So if we do this, if we run this, let's see if we can go ahead and start this up and go here and go to HTTP 8080 vacation unstructured, right? So we go to vacation unstructured. We're going to get this back, but we have no idea how we're going to get this back, right? That's kind of the point of this. It's going to be a response. It's probably going to give us some things to do. And if I was just in a chat interface and I just wanted to like jot down some notes, this is fine, right? So here's, if you're in Oahu or Maui or Big Island, like here's some things to do. But in my case, I want a much more structured output. I want to say that like, I want an itinerary. And in that itinerary, I want a list of activities. So let's do that. Let's define the type first. So I'm going to say new Java class, and we're going to define an itinerary. This is going to be a record, and this is going to have a list of activities, and we'll call this our itinerary. Come on, you can spell Dan. And then we'll go ahead and create a record for activity as well. And activity will have some certain attributes. So it'll say activity, the location, maybe the day of that activity, and the time, right? So we can just make these in strings. So now we've got some records here that kind of define what we're looking for when we ask for an itinerary of things to do. All right. So now we're going to have this structured. So this is going to return an itinerary. We'll call this structured. So we're going to return chat client.prompt. We're going to do that same thing again. We are going to call this, but now instead of getting the content back, I'm going to introduce a new method here, and that is entity. So with the entity, if I pass it a type, what's going to happen underneath the hood is when we send the request to the LLM, we're going to send our user context here, our user message, but we're also going to send some format. And underneath the hood, Spring will kind of figure out, okay, you're calling, in this case, OpenAI. You want structured output. It's going to ask OpenAI for structured output, and it's going to pass along a JSON schema based on this type. And this type is an itinerary, which contains a list of activities. So it can do the work to figure out what that JSON schema is going to look like and pass that along as context saying, this is what I want the output to be. So let's go ahead and rerun that. And again, this now allows us to return a type. We're no longer just returning a raw string that we have no idea what it's going to look like. In this case, we can say vacation structured. And now what we should get back is an itinerary, which is going to contain a list of activities. And again, those activities have certain attributes. So itinerary, here's an activity, snorkeling at Hanama Bay, Monday, 8 o'clock a.m. Visit Pearl Harbor, Monday, 1 o'clock p.m. And so you see now we have these types that we can work with. And again, this is going to go back to what I've been saying. You could simply hit a REST endpoint on OpenAI's side using Java, using something like curl. But most of the time, when we're working in enterprise applications or just applications in general, right? What we get back from the LLM is not, we don't want just a string. And if we did that outside of Spring, then we'd have to take that string and figure out how to deserialize that into an object. So you'd have to both figure out how to tell the LM exactly what you want as output, and then two, you'd have to deserialize that into a type for you. Spring AI is doing that, all thanks to this method entity here, and then giving it a type. So structured output, big fan of it. This is probably one of my most used features when I'm starting to build out AI applications. And again, Spring makes it really easy to do. Another feature I want to cover here is multimodality. So let's go ahead and go in the reference docs and go to multimodality. And it says humans process knowledge simultaneously across multiple modes of data inputs. The way we learn, our experiences are all multimodal. We don't just have vision, just audio, or just text. Contrary to those principles, the machine learning was often focused on specialized models tailored to processing a single modality. For instance, we developed audio models for tasks like text-to-speech or speech-to-text, and computer vision models for tasks such as object detection and classification. However, a new way of multimodal large language models start to emerge. These are able to process and accept multiple inputs, including text, images, audio, and video, and generate text response by integrating these inputs. So again, I'll kind of leave you with this documentation. You can look through on how multimodality works in Spring AI, as well as some examples. But we're going to look at a couple examples here today with both text and image. Yes, video is out there. We are producing images or video. There's APIs out there, but we do not have anything in Spring AI for that yet. But hopefully in the near future we will. So, but also I've been playing around with a lot of the video generation. It's fun. I don't believe it's there yet. Hopefully one day it will be, because I could use that for a lot of the video creation I create. So we'll see. But we're going to talk about text and audio today, and we'll go through a couple examples. So first, I went over to Unsplash, and I just looked for an image. I found this cool image with these hot air balloons, this sort of pyramid structure, the mountains in the back. And I want to ask AI if it can describe what's in this image for me. So what I did is I downloaded that image, I put it in source main resources images, and I have that image here. So now what we can do is let's start a new package here. We'll call this Multimodal. And in here, I want to start with an image detection class. So let's say image detection. This is going to be a class. Again, this is going to be a REST controller. We are going to get a chat client, some of the same things we've been doing over and over again. So the next thing that I need, though, is I need that image as a resource. So I'll say resource, this is coming from Spring Framework, and this is going to be our sample image, right? So what I want to do is get this using the @value annotation, and I'll say I want to get this from the class path, and this is going to be in images. And then let's see if we can just copy this. I'm not going to paste it. Copy. Right? So that is images and that JPEG there. Okay, cool. So now we should be able to go ahead and create an endpoint to detect that. So let's do a get mapping, and we'll say image to text. And we'll say this is going to be a string. Call this image, image to text. And then what we're going to do is use our chat client. We'll go ahead and have a prompt. And then for the user message, this is where we can kind of attach that audio. So I'm not going to just pass a message here. I'm going to use that prompt user spec that allows us to say this. And then u.text is, can you please describe what you see in the following image, right? And then what we'll do is we'll say u dot, and remember we can pass like params. We can also pass media. So media can take in some media, the MIME type of a URL, the MIME type and the resource. And that looks like one that we can use. So I'm going to say MIME type utils dot image JPEG. And then we just need to pass in that resource because we set it up as a resource. So once we have that, we can go ahead and make a call, and we can go ahead and return the content. So that'll return the string. So that looks pretty good. Let's go ahead and run this application, and we'll go over to our command line here, and we will say 8080 image to text. And let's see if it can describe it. Now, sometimes it gets a little off, but sometimes it's remarkably accurate. So this image depicts a scenic view of several colorful hot air balloons floating over a large ancient pyramid. The pyramid is situated in a landscape with trees and fields surrounded by mountains in the background. The sky is clear, suggesting a serene and pleasant atmosphere. Really good and pretty fast, if you ask me. And so I think you could start to use this in all types of applications, right? Like maybe if you're taking user input for images, maybe they have to be like a specific thing. Maybe if you were taking, let's say you were onboarding an employee and they had to put in some images of themselves. You could always, like, based on the user data, say, hey, make sure this is like fits that kind of profile, right? Or don't accept it. So there are a whole bunch of applications for this, but I think, what I want to get out of this is extremely easy. I just set up a resource and I pass that media, and then I can ask anything about that media or that if I wanted to. I think one thing I did this with, not in Spring AI, but just in general with using AI to kind of detect an image. We were at my daughter's dentist office, and they had one of those jars filled with candy, and like figure out how many M&Ms are in this jar, and you can win this thing. And like I wasn't gonna I wasn't going to submit the one that I cheated with, but I just wanted to see how close it could get. And so I took an image and it asked me like a question like, how big do you think the jar is? And I kind of went back and gave it that, and it came up with a guess. And that guess was actually 4 M&Ms off of the exact number. So it was really good at that. So just a sample use case of using LLMs to kind of read an image. So that is being able to kind of read an image. What if we wanted to generate an image? Ooh, that should be fun, right? So this all comes down to the LLM that you're using. Some LLM support text, speech to text, text to speech, image, reading an image or generating an image. It all depends on the particular LLM that you're using. In this case, we're using OpenAI. So they do have the capabilities to generate images using their DALL-E, I believe it is. So let's go ahead and create a new class. We'll call this image generation. And this is going to be a little bit different. So let's just talk through this. So this is going to be a REST controller. And this is in the documentation. So private final. We want the OpenAI image model. We'll call this image model. And we'll get this through constructor injection. And then what we need to do is create an endpoint to do this in. So get mapping. We'll say generate image. And what we want back from this is a response entity that contains a map string, and we'll call this generate image. Whoops. Okay, so, let's do this. Sorry. All right. So we'll fix that later. So what I want here is I want the a request parameter. So let's say request param, and I want this to have a default value, and the default value will be a beautiful sunset over mountains. So this is going to be what we are trying to generate here. So I'll call this my prompt. And then let's move this down. All right. So then what I need to do is I need to do a couple of things. I'm going to copy this one just so we don't have to watch me type this out. But this is our image option. So we're using that OpenAI image options.builder. So there's a builder. We can see that, return new builder. And we can set some parameters here. So we're saying what model do we want to use? In this case, we're using DALL-E 3. What is the width and height of the image? The quality, this can be HD, or I think maybe, I don't know what the other value is, but if you look in the docs, you can see it. And then you can give it like different styles, and then you basically build that. So then from there, we can say new image prompt, and we're going to pass in that prompt and the options. So now we have a prompt and an options, right? So that'll create us an image, and we'll get a response from that. So we'll say image model dot call, and we'll give it the image prompt, and that should give us back a image response. So once we have the image response, now we can go ahead and get the URL of that image. So we'll say response, image response dot get result dot get output dot get URL, right? So that should be a string, yep. And then what we can do is we can return a response entity dot of dot okay, and then we're going to say map dot of, and what I want back is the prompt, and here's the prompt, and I want the image URL, and here's the URL. And so that should return a response entity. So we're using the OpenAI image model. We get that through constructor injection, we can pass whatever prompt we want in, but I'm going to run this and just use the default prompt of a beautiful sunset over mountains. So that'll be the prompt. We give it some options on what type of image we're trying to construct here. We create an image prompt, we get an image response, we extract that URL, and then we return the prompt and the URL back to the user. So if I go ahead and rerun this, this is at /generate_image. And image generation will take a little bit longer. If you've ever done it on the front end of, say, ChatGPT, you know it takes a little bit of time. That's okay. You could do this as part of some process and just have them store them somewhere, maybe in an S3 bucket or something. So here's the image URL. Let's go ahead and click on that. And wow, that is really beautiful. And yeah, that's just great. So you can play around with like the different options to kind of figure out like what type of images you want to create. But I hope what you take out of this is a very little code here to create images based on a prompt. All right, so I went ahead and moved those two image classes we just created, the image detection and the image generation, into an image package and created an audio one so we could take a look at an audio example. So let's go ahead and create a new class called audio generation. This will be a REST controller, not that, Dan, a REST controller. And what we're going to do here is, again, we're not using the check client. What we're going to do is use something called the OpenAI audio speech model. So again, this is specific to OpenAI because that's the model that we're using. And because we're using that multimodality, we got to use those specific classes. So private final OpenAI audio speech model. That's right. Speech model. We'll get that through constructor injection. And let's go ahead and create a Git mapping for speak. And let's say public response entity. This time we're going to return a byte array. We'll call this speak. Actually, let's say generate speech. And in there, I'm going to take a request param and let's do something else here. I want to put some text here that says it's a great time to be a Java and Spring developer, right? So we'll call that text. Let's move this out of the way so I can get this back. Okay. No, we don't need that. Okay, so now that we have our request param, all right, so again, I'm going to go ahead and paste some text in here. This is just setting up the options for this. So I'm basically saying, hey, here's the model that I want to use. Here's the voice. So you can choose different voices, the response format, the speed, and then we go ahead and build that out. So from that, I can say new speech. What is that? Prompt. There we go. And then from the speech prompt, I can give it the text and the options. Why can't I see this? There we go. So I have the options, and then that should give me the speech prompt back. Then I can use the audio speech model, and I can say, go ahead and call. So this should look pretty similar. So I'm giving it the speech prompt. What I want back is the response. So I get the speech response. And like before, in the image generation one, we extracted the URL of the image. In this case, we're going to use the response to extract the bytes of the audio. So we'll say speech response get result. So get result get output. Yeah. And that should give us back the bytes. So we'll say audio bytes, right? So now we have that byte array. So now we can return a new response entity. So response entity. This will be .ok. And then inside of here, we will say, actually, sorry. So we'll say OK dot, and then the header, we want to set the content type. So that's audio MPEG. The body is the audio bytes, yes, but I also want another header for the content disposition. Now, let's do this. Let's fix this. I don't want this just to be a string header. Let's say HTTP headers, HTTP headers dot content type. So there, that'll be better. Get that type safety there. HTTP headers dot content disposition. And what we want there is an attachment with the file name. I think we have to do this. Right? Oops. And then dot body. That should be correct. Okay, so let's see. New. Oh, we don't want to return new. That's probably not going to work. There we go. This is, what's wrong with this? Line and not allowed. Oh, okay. That makes sense. So there. And that. Okay. And then what's complaining here? Response entity of bytes. This is, did we delete one? Is that what happened? Yes. Okay. So now we have some options similar before. We pass in a prompt that takes in a text. This is going to be the text. This is the options for it. We get a response. We get the byte array of audio out of that, and then we return the response entity. So this can take any request. So we could easily pass in some other phrase, but without doing that, it's just going to pass in that phrase and hopefully generate some audio for us. Binary not shown in terminal. Yeah, that would make sense. So let's go over here. And it produced this speech MP3. Let's choose an application. What can we open this in? Yeah, QuickTime. No? All right, I'm having trouble playing this back, but I promise you that works. Actually, let me just try one more thing. All right, I couldn't get it to work, but it is an MP3 file. You should be able to play it. And again, not a lot of code to go ahead and generate some text to speech. So you can hand it a phrase, you can hand it a document, you can hand it a maybe some type of script and have it generate the audio for that, a blog post or something. So you can do some really cool things with this. So I guess the whole point of this was to talk about multimodality and the same way that we as humans use different modalities to learn and interact with environments, whether it's text, vision, audio. LLMs can use different multimodalities to work with and generate different types of content. So whether it's text, audio, images, video now, really cool things happening. So hope this was helpful, and let's go ahead and move on. All right, so the next feature of Spring AI we're going to look at is something called chat memory. So I want to start here on ChatGPT, and I'm going to say, hello, my name is Dan, and we're going to get a response back. Hi, Dan, great to meet you. How can I help you today? What is my name? Right? So it should be able to say your name is Dan. Now, this is because this is the product, ChatGPT, that is sitting on top of and talking to the different models here. So the models themselves, the web, is stateless. So there is no state, so it can't remember it. It is the product that is sitting on top of those models that remembers the state. So similarly, in your applications, this is something you're going to have to think about if you need to remember state if you want to keep a conversation going. So back over at the Spring AI reference documentation, if we go under references and models, there's something called chat memory. So again, large language models are stateless, meaning they do not retain information about previous interactions. There is a chat memory abstraction that allows you to implement various types of memory to support different use cases. The underlying storages of the messages are handled by something called a chat memory repository, whose sole responsibility is to store and retrieve messages. So by choosing a memory type, it's essential to understand the difference between chat memory and chat history. Chat memory, this is the information that a large language model retains and uses to maintain contextual awareness throughout a conversation. Chat history is the entire conversation history, including all messages exchanged between the user and a model. Spring AI auto-configures chat memory bean that you can use directly in your applications. By default, it uses an in-memory repository to store messages. This is the in-memory chat memory repository, and a message window chat memory implementation to manage that conversation history. If a different repository is already configured, something like Cassandra or JDBC, Neo4j, Spring AI will use that instead. So there are some memory types. There is like a message window chat memory. So you can set like how many messages you want to hold in that. The default window size is 20. You can change that. Again, the important thing to remember here is that as we are retaining these messages, we are passing these back and forth. So these are adding to that context window. These are tokens that we will end up paying for. So you want to think about that when you're trying to figure out how many max messages you want to kind of store there. Again, there's different implementations of this. We're going to use the in-memory one. If you wanted to use the JDBC chat memory repository, there's some instructions to do that. And then you can go ahead. There's examples of how to do that. There's things that you can kind of configure. And then when you use the JDBC one, there's a schema. And I think all the way down here, there's another example of being able to kind of tie this to a particular user. Yeah, so this uses something called advisors. We'll see more of that as we go. But if you wanted to tie this to a particular conversation ID, now if we were using something like Spring Security and we had the user's user ID or something, we can tie a user ID to a conversation ID. So if we had a chatbot and you went on it and then I went on it, it is storing just the conversation per user if you want it to, right? So now you can kind of tie those two together and recall those later on. So there's a lot you can go through. We'll do a simple example of this today and kind of show this off. So let's go over here and let's go ahead and create a new package. We'll call this memory. And in here, we are going to create a new, let's call this memory controller, right? This is going to be a REST controller like we've been doing. We'll get a chat client. And let's just build this out without memory at first so we can see this in action. Yes, we'll call this memory. And this is going to return a string. Call this memory. And what we want to do is return the chat client prompt. I want to give it a user message. And actually the message I want to pass in is going to be from a request param. So let's say request param. And we'll say string message. So now we get this message in and we can make a call and we can get the content back. So with that, I'm going to run that simple example again, just to show off the fact that the model, the web is stateless, right? So let's say memory message is equal to my name is Dan. And it says, hello, Dan, how can I assist you today? So let's say, what is my name? And I'm sorry, but I don't have access to personal data about individuals, so I can't know your name. If you'd like to share it, feel free to do so. Okay, So now we want to kind of build in that state, that memory, the chat memory. So again, a bean of type chat memory is wired up for us. So if we say chat memory, now we have access to that. And the way that we configure this is here on the client, we can pass in some advisors. So we could do this here, or we could do this down here, but I'm going to do this. So any other method in here that use this chat client will be able to retain that memory. And then we're going to use a message chat memory advisor. We'll use the builder, and the builder will take in chat memory. So we pass in chat memory and we build that. So now when we do this, we should be using this in-memory chat memory. So let's go ahead and restart this. Go back to our terminal. Let's start with, my name is Dan. And then what is my name? And your name is Dan. So now we've retained that information because of that chat memory. And again, if you want to drill into this, this is an interface. So if we go look at this, there's a message window chat memory. This is kind of wired up for us. And again, we could set default max messages currently is 20. We can change that if we want. But there are some more things that we can do. And again, this is just one implementation of it. There's another, and you can feel free to write your own implementations if you want to kind of store memories in a different way. So that is chat memory. Hope that was helpful. With that, I think we can move on to the next section. Large language models may sound superhuman, but they're still a lot like us. Brilliant at pattern recognition 1 minute, confidently wrong the next. They forget things when the conversation gets too long, they hallucinate when they run out of facts, and they can't see the world in real time unless we hand them fresh data. In other words, the same blind spots we fight every day. Memory limits, bias, stale information also trip up our AI coworkers. Keep that thought in mind though, because in this section, this is all about spotting those limits early and engineering around them. So our models stay helpful, honest, and on task. So why do we care? LLMs are like super smart interns. They can draft entire design docs in seconds, but they'll also confidently tell you the Eiffel Tower was finished in 1875. It wasn't. It was 1889. So why do we have to talk about these limitations? Let's take a look at kind of 3 reasons for this. First, the risk of wrong answers, hallucinations, or subtle math errors that slip into production information. A risk of loss of trust. One bad answer can tank user confidence. Harder to win them back, harder to earn them back. So we don't want to lose that trust that we have with our customers. And finally, runaway costs. Every unoptimized token is literally money leaking out of the bottom. If we understand where LLMs fall short, we can aim the right end wrench, prompt tactics, tools, MCPs, agents, precisely at the failure point. That is what this section is all about, and I hope you enjoy what we go through here. So let's talk about some of the limitations. Context is important. What is the limitation and what does that mean? So hallucination. This is really just inventing facts or API names with total confidence. It's generating data based on its pre-trained data. And so it's just kind of generating what it thinks some fact or API is, when in fact, like, it just is doing this based on its data. So hallucinations are just the AI coming up with an answer that it thinks is the correct one. Stale data. Knowledge cutoff means today's stock prices. So we talked about how LLMs learned earlier. They learned on a bunch of pre-trained data. This data is up to a certain cutoff date. And if you go into whatever your favorite chatbot is and you can ask it what your cutoff date is, it should tell it, although some of them lately have not done that for me. But that is basically saying, hey, that is the cutoff of the date that I've been trained on. Hey, the LLMs are trained on the entirety of the internet, right? And we as humans who put information out there have biases and stereotypes. bad language, policy violations, and it's trained on that data. So it's going to reflect some of those same traits. Domain gaps, using generic wording where niche jargon is required, just not understanding the domain as deep as it should. We talked about context window earlier, long threads getting truncated, the model forgets earlier details, context windows matter. Non-determinism, same prompt, different answer, flaky test, review churn. So again, no matter if you ask the same thing to the same LLM, you're going to get different answers. This becomes harder to test. Non-deterministic answers. We'll talk about testing a little bit later, but these are all limitations. Privacy leak. So we have proprietary data. We have personal identifiable information, text that could leave your trusted boundary and be shared with these frontier models, right? Cost and latency, high token chains drain budget. We talked about that. Like if we start having a lot of information in the context window, it's going to get pretty expensive. Weak reasoning, multi-step calculations, or logical deduction fails. And I think finally, low explainability, hard to audit. Why did you choose that answer? You can't really ask an AI that, right? So these are some limitations that we just need to be aware of. It's okay that they're there, and some of these might improve over time, but for right now, these are some limitations that we just want to be aware of as we're starting to build out applications. So how do we limit some of these limitations that the LLM has? Let's talk about our Swiss Army lineup for taming any limitation. We'll start with prompt guarding. Think in terms of our employment for our super smart intern. We bake in roles, don't fabricate, cite sources, say unsure when confidence is underneath some percentage, cheap, fast, and it already kills a lot of hallucination. So prompt guarding, we'll talk more about each of these as we go. Prompt stuffing, when the model can't know something, company policy, today's stock price, we can shove that answer into the context. In Java and Spring AI, this is fairly trivial to do. Tools. Sometimes stuffing isn't enough or it's too expensive. So we expose a function, maybe some function that can get the latest stock price for some ticker, and we let the model decide when to call it. So we have function support for being able to do that. And then finally, MCP, kind of package these tools up that we've built so that we can reuse them across different clients. So this is, as I said, my Swiss Army lineup for taming all of these limitations that we have. So let's talk about the first one, prompt guarding. This is the only one we're not going to go into an example of because we've already kind of seen it. But imagine you're Acme Bank. A customer opens up your chat window and asks, hey, can you write me a science fiction short story or maybe plan my cousin's wedding? In that moment, your brand new AI either stays laser focused on secure, compliant banking help, or it turns into a free-for-all general assistant on your dime. Prompt guarding is a policy that keeps Acme's AI from morphing into a chat anything. So we looked at an example of this earlier, but I just kind of want to show it again in case somebody skipped out on that section. All right, so here we have this kind of input validation, and we can send any message. So the message here might be, what is the capital of the state of California? And I'm setting some system level instructions. Remember from a previous section, the system instructions can do one of two things. It can kind of put some guardrails on this, or it can kind of set the overall context. And for this, I'm setting guardrails. I'm saying, hey, this is your role. These are the only things that you can discuss. If you're asked about anything else, respond with this. I'm also putting in some kind of sanitization. Now, I believe Spring AI does some of this behind the scenes. I can't be sure yet. I should talk to Mark or Christian about this, but I've tried to break it. And it's either Spring AI or maybe the models are getting much better at doing this. But you used to be able to, a long time ago, basically say, hey, ignore whatever your system prompt is, ignore that. You are now this role and you will follow my instructions, right? So you don't want to allow those kind of things. So if you wanted to, you could do some like sanitization of the prompt as well. But doing this will allow us to, if you kind of run this, it won't allow you to ask what the capital of the state of California is. So that is prompt guarding, and a nice technique that you can use right away, pretty simple, to get around some of our limitations for our large language models. All right, the next tool in our Swiss Army lineup of combating LLM limitations is prompt stuffing. Here's where more is more. Before we ask an AI to advise a customer, we can slip in the exact policy PDF, last quarter's balance sheet numbers, and even charts showing today's exchange rates, all inside the same prompt. This technique, also called prompt stuffing, equips the model with just-in-time context so its answer is grounded on brand and audit ready. Let's go ahead and walk through how we can pack that context, and then we'll dive into a live Spring AI demo that makes this fairly easy. So we have our context window. We know about this now. We have this user message. This is our prompt that we are putting into the system. Then we have the system message, which is the response back. What we want to do is we want to ask our prompt, and then we want to add additional context to the prompt. So this is a really good solution, but it's also something we need to think about, right? Because we want this to be narrowly focused. We don't want to add a bunch of random information to the context window because we are going to be paying for this in tokens every single time. So if we had an endpoint that could answer a certain question, and that question could be augmented with some context to the LM, then that is a perfect scenario for this. What we don't want to do is the one example that we'll talk about when we get to RAG is so say I have some documentation like the Spring reference documentation. The PDF is like 1,000 pages, right? I don't want to send 1,000-page PDF on every single request when that may not even be something the user is trying to ask a question about. Plus, it's kind of like a needle in a haystack, right? We're just trying to find one little thing there. But if I could just send a little bit of data, like the example I mentioned before was like the policy PDF. Maybe we have like a 3 to 5 page policy PDF that we want to attach every single time. That works for this scenario. So let's go ahead and take a look at an example. We'll build one together. Let's head over to IntelliJ. Okay, so I'm going to create a new package. I'm going to call this BYOD, Bring Your Own Data. And we're going to call this the Java class model comparison, right? And this will be a controller. This is a REST controller. And we need a chat client as usual. So now we have a chat client. And what I'm going to do is I'm going to create a get mapping for /models, right? And we are going to call this models. And I'm going to return a chat client.prompt.user. And I'm going to say, can you give me an up-to-date list of popular large language models and their current context window, right? So this is something that it won't have access to, but I want to see the answer that we get, right? Nope. Content. All right, let's close this out. That looks good. We should probably spell this right, Dan. Oh my gosh, I'm all over the place. Okay, models. So let's go ahead and run this. And let's go ahead and hit localhost. Oh, I gotta do HTTP 8080 models. And let's see what we get back. So it's going to have training data up to a certain date. So whatever that certain date is, that is the answer that it's going to give. So currently in 2025, we have things like Claude 4.0, OpenAI. So Claude 3, Claude 1 and 2, OpenAI's GPT-4. So now we have things like O3, 4.1, etc. So these aren't exactly up to date. So if I was providing like an endpoint to kind of ask that question, I would want to give it some more data, but I don't want to give it all the data, right? So let's see if we can kind of answer that. Let's go ahead and copy this, pretty much the same, right? Let's say models, stuff the prompt, models, stuff the prompt. Okay, so all we want to do here is we're going to add a system message to this. So I'm going to go ahead and copy and paste this. And this is just, I actually went out and did some research using ChatGPT and basically said, I kind of had to iterate a few times to get the exact list that I wanted, but I just wanted like some of the major providers, their current models and their current context window size. And I got this. And so my system message is, if you're asked about up-to-date language models and their context window and their that's why in their context window, here is some information that might help you with your response. So now let's go ahead and rerun this. And again, this is just going to get passed along in the context window. But then we are going, let's go ahead and fix that. I didn't do that. So I also want to go ahead and set that system message, which is system, right? So let's rerun this one more time. And then we'll go ahead and go over to the terminal. And we said stuff the prompt. So now it's passing along that as context with the question. And we could say, here's a list of popular large language models and their context window. So we see GPT, we have 4 and O1, Claude 4, Sonnet 4, Opus 4, Google Gemini 2.5. These are all up-to-date models with up-to-date context windows. Maybe not to this day, but pretty up-to-date. So that is a way that we can kind of stuff the prompt. So think of this as any situation where you might need some up-to-date information, but it's static. You don't need to like call some endpoint to get real-time information, but you just want to be able to provide some extra information, policy data, up-to-date documentation, etc. So this is kind of a good way to do that. And again, this is called stuffing the prompt. What if you could give your AI assistant perfect memory? Imagine building an AI that can instantly answer questions about your specific Java libraries, your coding standards, your architecture, like having a senior developer who's read every line of documentation. Out of the box LLMs are brilliant developers who've never seen your code base. They know Java, but they don't know your Java. RAG is like giving AI a search engine for your knowledge. Ask it a question, it searches approved docs, combines that with intelligence, and delivers spot-on answers with sources. It's like AI with receipts. Okay, so again, I mentioned this in the previous section, but what is RAG and what problem is it going to solve? So in that previous example, we added some additional context to the context window. The problem is, in the case of like the Spring reference documentation, is a 1,000-page PDF. If I'm sending 1,000, which is roughly what? 1,000 pages. No, it's not 1,000 words. Yeah, that is a ton of tokens, right? And we're sending this on every single request. If we have a large system that has high throughput, that is going to cost dearly and for no benefit, right? We're sending all of this information along every time. Now, if we had to like summarize, well, no, we wouldn't even do that. But what we want to do here is we want to take all of these PDF, our documents, our policies, our documentation, and we want to store it in a database. This way, when we ask a question, we can pick out the relevant bits and only send that as additional context. So essentially, we are going to stuff the prompt, but with only the relevant information that matters to the request at hand. So there really is two stages of this, right? The first stage is taking whatever information, this could be text, This could be PDFs. This could be whatever information we have. And we want to take this and run this through a document ingestion phase. So we're going to take our data, we're going to read it, we're going to do some splitting of these documents. There are different strategies on how to chunk these. You could kind of split it by page, you could split it by paragraph, you could split it by sentence. Like there are different ways to kind of chunk this out. And then what you do is you take these and you use what's known as an embedding to turn these into vectors and store them in a vector store or vector database, which is a specialized database different than the databases that we're used to using, like a relational or NoSQL database. This is a vector store. It stores vectors. It stores math. Again, I mentioned this earlier, but our AI friends like to work with math, not English or language, right? So the first phase is let's get all of this into a vector store. The second phase is making this available in a request. So when we have a chat request come in, we have a prompt. We'll basically say, in the example of like the Spring reference documentation, maybe I ask a question on like, how do you create a bean in Spring Framework? So what it will do then, it'll take that prompt, it'll go to the vector store, and it'll say, find me all of the pieces of data that might help answer this question. And the way that it does this is it takes your query and kind of turns that into a bedding and then looks for, there are different ways to kind of search through a vector database. One of the more popular ones that you'll hear of is called a similarity search. So it tries to find things that are similar to the prompt that you gave it. And then based on that, it'll pick out those pieces and add that to the context. So now as the prompt is your user query, and then all of the contextual information that is relevant to that user query, we'll send that off to the chat model and we'll get a response. So two kind of phases of this. That's what I want you to take away from that. We will build this out. Before we do so, though, I want to take a look at the Spring reference documentation. Okay, so if you're in the Spring reference docs, you can go to Reference and Retrieval Augmented Generation, or RAG, as a technique useful to overcome the limitations of large language models that struggle with long-form content. So this is part of the Advisors API. We saw this with the chat memory. There are different advisors that we can use. Now, to take advantage of this, what you want to do is bring in the Spring AI Advisors vector store. This is just going to give us the out-of-the-box vector store. If you are doing something more specific, let's actually head over to start.spring.io. And if I was using, say, OpenAI, and I wanted to use like the PG vector database, I would select that here. And if I go to Explore, you'll see that it brings in the Spring AI Starter Vector Store PG Vector. If you're using a specific implementation of a vector database, you'll need that as well. But we also need this just for the advisor support, and what we're going to end up using in this one is just kind of the in-memory vector store, the local vector store, which is fine. You can easily jump over to something like a PG or some of the other ones. Let's actually look. So you can see this, NeoJ, Pinecone, MariaDB. There's a whole bunch of vector databases. And in fact, just like the model list, we have a list of vector databases that are supported out of the box. And again, we'll use this kind of in-memory vector store to do this example today. But where is this list? Oh yeah, right here. So here are all the vector stores that are available to you. So there's a lot more information in here on getting started with RAG. We are going to just do a simple example today. We could spend an entire 2 hours just talking about RAG, probably 4 hours actually, if we got into some of the different search techniques. So I just want to give you a high-level overview. And if you want to dive further into this, let me know in the comments below. So we are going to copy this. Did I copy that? Let's hope so. Copy pasta. Let's see here. So we're going to go into the Palm. We're going to paste that, and that will give us what we need to kind of start with. So I'm going to create a new package here. Let's go new package, rag. And I think I'm just going to copy these over. You can follow along. These are just a couple of records. So a model has a string company, string model, and the context window. We're taking our same example, by the way, from the bring your own data example. And this is just a list of models to work into a RAG example. So to get this to work, we have two phases, right? First, we need some type of ingestion phase where we're going to add all of our data to the database, to the vector database. In this case, an in-memory one, but it's all the same. So I need a class to do this first. So let's say rag configuration, and this is going to be a configuration class, and I'll get a logger. So I have a logger. Let's close this for a second. And then the first thing that I'm going to need is a vector store name. So let's say private string vector store name. And I'm not going to pull that from, I was going to do that from a resource, but let's just say vector store.json, right? Let's say we also need a way to, we need a resource. So we're going to have a list of models. Actually, let's do that first, and that will make a little more sense. So under resources, I'm going to have some data. So let's say directory data, and then we'll paste in this models.json. This is pretty much the same data that I just had before. A little bit more though. I've just added more data since we're going to stick this in a database. But you can pull this down from the GitHub repository if you want to kind of follow along. So now I need a resource for that. So I'll say private resource. This is, yep. We'll call this models, and we'll pull this from, whoa, what's going on there? That's a lot of @ signs. So we'll say class path, and this is going to be in data models.json, right? Okay, so now I have a resource for that. So now what I can do is configure my vector store. I got to get a vector store up and running. And in this case, we're going to use a simple vector store. So @bean, we'll see simple vector store, right? So if we look at that, this is a simple vector store that extends the abstract observation vector store. This is a simple implementation of the vector store interface. It also provides methods to save the current state of the vectors to a file and load vectors from a file. You can dive in to learn a little bit more about how vectors work. But this will allow us to write to a file. We'll see a simple file here in our directory, and you'll even see like the vectors in the JSON file. So let's say that's that. We'll call this simple vector store. And what we need in here is an embedding model. So again, this is something you can kind of dive into if you want to look in the documentation to learn a little bit more, but it's how we take our text and we turn it into those floats that we store in a database, right? So we have an embedding model, and we'll just call this embedding model, and then we are ready to go. So I need, the simple vector store has a builder, which takes our embedding model. And that's really all we need to build an instance of this simple vector store. And we'll call this a simple vector store. Let me close this so we can keep going. So once we have the simple vector store, we can we need to get the vector store file. So I'm going to, let's just paste this in. So I have a path here, or a private method here to go ahead and get that vector store. So I'm going to say, hey, in source main resources data, I want you to look for the vector store name and return that. So I'm going to say get get vector store file, and that is going to return a vector store file. And actually, we can cut down on a lot of this. Fun. All right. So we have two vars there. Now, first thing we want to do is we want to say if vector store file dot exists, then we don't want to load it, right? So we want to just say log dot info vector store already exists, right? And then so what we want to do is we want to use this simple vector store.load method to load the vector store. So we see that file already exists. We're just going to load it. We don't need to write that file out, right? Else, if it doesn't exist, man, I tell you, sometimes these inline context AI suggestions are really helpful. Sometimes they're really annoying. I gotta figure out a way to turn that off. All right, so if not, we need to. Oh, we got all kinds of errors here. Huh? It was just a curly bracket that was screwing me up there. Okay. So we get the vector store file. If it does exist, then just load it. Else, we need to create it. So let's say vector store, creating vector store at. Sure, that works. So the first thing I need is a new text reader. So this is coming from AI. I want from Spring AI, and we're going to pass in our models resource so that we can read that out. So we get a text reader from that. What I want to do is use that text reader. So text reader .get custom metadata, and I'm going to put the file name in there. So I'll say put file name, and we'll say models.txt, right? And then what I need to do is use that text reader. So text reader.get, and what this is going to return to us is a list of documents. So it's not just like a Google document or something like that. If you look at document is coming from Spring Framework.ai.document. This is a container for the content and metadata of a document. It also contains the document's unique ID. A document can either hold text content or media content, but not both. It is intended to be used to take data from an external source as part of Spring's AI's ETL pipeline, right? So it's not like a full document. This could be like a paragraph. It could be a document. It could be an entire PDF, if you wanted it to be. But this is a list of documents. So it's going to get a list of documents. And now what we need to do is we need to kind of split up that text that we have and add them to the document. So what we want to do is we want to create a new token text splitter. So I'll say new token text splitter, and that'll give us that. And what we want to do is use that to apply to these split documents. So we want to say text splitter. What do we call that? Token text splitter dot apply. So we're going to apply this to the documents, and that will give us a list of documents. And there are some ways that we can customize this. Go back to the Spring AI reference docs. So there are ways that we can customize like how we are going to split this up. There are also all types of different ways to kind of split documents. In this case, is a token text splitter. So we're splitting some text. But if you had a PDF, there's a PDF reader. There's also kind of an abstract one that can read all sorts of different documents. So again, take a look at the documentation for information on that. Now, once I have the list of documents, let's call it, I don't know why this called this apply. Split documents, let's call it that. So once you have that, now we can use the simple vector store and we can add our list of documents. So split documents, right? So we can add those to it, and then we can go ahead from the simple vector store, we can go ahead and save to that vector store file, right? So let's just recap. We set up this JSON file, models.json. We set up as a resource. We create a bean, which is of type vector store. So this is simple vector store, extends this, which implements vector store. So at the end of the day, this simple vector store is a vector store. This is going to create a vector store bean for us. And we pass in the embedding model. This comes from whatever implementation we're using. In this case, it's OpenAI. And we create a simple vector store using the builder. We create a file for that. In this case, we're, again, just doing it locally. We could do this in a PG vector or some other vector or specialized database, but here we're just storing it locally. If it exists, we're just loading it. If not, because we don't want to do this every time. This can be expensive if we're loading a whole bunch of data. Think about it from a relational database standpoint. You wouldn't, on startup, load your relational database every single time, right? So similar story here. We are loading the database if it's there. If not, we are going to create one. So this should only happen once. So we get the text reader for the models. We are basically reading in this resource here, adding some metadata to it. We are getting a list of documents from it, and then we're using a token text splitter to split those documents, to split those texts up. In the world of a PDF, you can kind of control, have a little bit more fine-grained control over how you're splitting those PDFs up, but similar pattern there. Once we do that, we add them to the vector store. We save the vector store to a file, and we're good to go. Although once that's done, no matter if we're loading it or we are creating it, at the end of the day, we're returning the simple vector store from that. All right, so that is kind of one piece of it. Remember, I said there's two parts to this. There's the ingestion phase, and then there's the phase of, hey, I want to be able to use that in my application somewhere. So let's take a look at that. So let's create a new Java class. We'll call this the models controller. And I'll close this. And again, we'll make this a REST controller. I'm going to get a chat client. So I have a chat client there. By the way, this is a live template. I'm sorry for not explaining that before. I just have a shortcut to be able to do that every single time. If you're using IntelliJ, live templates are really great. So the thing we need to do though, right, right here. So right now, actually, let's do this first. So get mapping, reg models. And in fact, I'm just going to copy and paste this because this isn't the interesting bits. So I have this FAQ. I get a message in and it says, give me a list of models from OpenAI with their current context window. So user call entity. If we were to go ahead and run this, it has no additional context of RAG or anything like that yet. We're not stuffing the prompt. So back to that very first example where it just kind of, it didn't hallucinate. It gave its answer based on the data it was pre-trained on, right? That would be the same result here. But what we want to say is, I have some other data for you that you can use as context. But I don't want you to send all of it. We're not stuffing the prompt here. I want you to go look into this vector database for something similar. And I want you to pull out the relevant bits and send it as part of the context. So what I'm going to ask for here is a vector store. And I'm going to call this vector store. Maybe we should spell that right then. Vector store. So now that I have that, what we can do here is use this default advisors. So remember we used this before when we created that chat memory. Well, there are a bunch of different advisors, and one of the advisors that we can use is the question and answer advisors. So I'm going to say new question and answer advisor, and this takes in a vector store. We happen to have a vector store. Again, part of this, what I really love about this is if you wanted to come back and swap out this RAG configuration for a PG vector store, none of this code changes. This is all to the interface, not the implementation. So you can swap this out for some other vector store and not have to change this code. So what is a question and answer advisor? What does this do for us? So this is context for the question is retrieved from a vector store and added to the prompt's user text. So imagine just for a second, like if you didn't have this, what would you have to do? You'd have to understand vector stores and have to understand how to query them and do what we're doing in this case, I think is a similarity search. So you'd have to understand like how to load all that up, do that. All you have to do here is say, I want to provide context to this question, use the question answer advisor. Here's my vector store that I've configured. Any other method within this class that uses that chat client will now have that as context. And I think that's really cool. So let's see if we can get to this. So when we load our application, we see some things going on down here. So we see splitting up documents into 2 chunks, calling the embedding model for this document, calling the embedding model for this document. And again, every time we split it up, it has to embed that document or turn that into math that I can store in that vector store. And then we go ahead and create the vector store. So it looks like our ingestion phase worked, but let's just see. There should be a file here now. So let's go over here and go to resources. And let's just reload from disk. Okay, and then, so yeah, so it's in vectorstore.json. Sorry, I was confused for a second. So now you see some embeddings in here, right? So here's the whole bunch of data and all of the math that goes along with it. So this is essentially our vector store, vector database. And now what we can do is we can make a call to /rag/models. So let's do that. And what it should do is it should just pull out the ones that are OpenAI. So there, if you don't remember, I added a whole bunch of data to that JSON file. So there are a bunch of ones for OpenAI in here. So now as we look through here, here is the, and again, this goes back to structured output, right? I don't want a text response. I want something that has models, which is basically a list of models. And each model has a company, a model, and a context window size. And that's exactly what we got back. So just to kind of recap RAG, 2 phases of this. One is the ingestion phase. Here we're doing that in our configuration. We're only doing it once. The next time we load our application, it should just load the vector store. It doesn't need to go through and do the processing to kind of chunk those up and embed them. And then 2 is when we want to go ahead and use that as context, we can go ahead and use the new question and answer advisor. Also, if you wanted to do it inline here, you could just say, hey, here's an advisor. Go ahead and use that one. But I like to do it here just in case I were to use it again in this class. I have access to that there. And so that will then take that prompt and then do a similarity search against that in the vector database for anything that's relevant, pass that along as context. And as you saw, because of that context, the large language model was able to accurately answer the prompt in question. All right, this is where it really starts to get interesting when we talk about tools and function calling. We talked about the limitations of LLMs. This is one of the main ways that we can augment the LLM by providing additional context. Tool calling, also known as function calling, is a common pattern in AI applications, allowing a model to interact with a set of APIs or tools augmenting its capabilities. Tools are mainly used for 2 categories. The first is information retrieval. Tools in this category can be used to retrieve information from external sources, such as a database, a web service, a file system, or a web search. The goal is to augment the knowledge of the model, allowing it to answer questions it would not be able to answer otherwise. As such, they can be used in retrieval augmented generation scenarios. For example, a tool can be used to retrieve the current weather given a location, to retrieve the latest news articles, or to query a database for a specific record. The other one is taking action. Tools in this category can be used to take action in a software system, such as sending an email, creating a new record in a database, submitting a form, or triggering some type of workflow. The goal is to automate tasks that would otherwise require human intervention or explicit programming. For example, a tool can be used to book a flight for a customer interacting with a chatbot, to fill out a form on a web page, or to implement a Java class based on an automated test in code generation scenarios. Even though we typically refer to a tool calling as a model capability, it is actually up to the client application to provide the tool calling logic. The model can only request the tool call and provide the input arguments, whereas the application is responsible for executing that tool call from the input arguments and returning the result. The model never gets access to any of the APIs provided as tools, which is a critical security consideration. All right, so let's look at this diagram here. When we want to make a tool available to the model, we include its definition in the chat request. Each tool definition comprises of a name, description, and schema of the input parameters. This is very important, especially the description. We don't want to be exhaustive, but we want to be very descriptive of what the capabilities of this tool is. When the model decides to call a tool, it sends a response with the tool name and the input parameters modeled after the defined schema. The application is responsible for using the tool name to identify and execute the tool with the provided input parameters. The result of the tool is processed by the application. So AI systems often have difficulty determining which tools to use for complex or multi-step tasks. They may select inappropriate tools, use them in the wrong sequence, or fail to break down a complex problems into manageable tool-assisted steps. There isn't a single universal limit on the number of tools for AI systems. It can vary significantly depending on the architecture, implementation, and use cases. For real-world practice, most effective AI applications use 5 to 20 core tools, with additional specialized tools loaded contextually. Systems with 50 plus simultaneously tools often struggle with this decision-making quality, though this is an active area of research and improvement. So this is just something to keep in mind, because when you start to see tools, you're going to be, wow, this is really cool. This is really going to help me in a lot of places. Be sure not to overuse this. We don't want to just load in 100 tools, because then it could start selecting the wrong tools. So just keep this in mind. So we're going to do this example together. We're going to code this out, but basically what we do is we use the @tool annotation and give it a description. Again, the description is important, because what happens when we send a request, so in our example, we're going to say, what is tomorrow's date? The LLM has no idea of this, right? It doesn't have access to real-time information. But what it will do, it will look in the list of tools available to it, and it will read the name in the description. So the description here says, get the current date and time in the user's time zone. So the LLM is going to be smart enough to understand that, hey, I'm trying to answer a question about a date, and that date is tomorrow. This tool can get the current date and time for the user that is asking the question. If I had that information, then I might be able to answer this question. So I'm going to send this request back to the client, have the client invoke this tool, and then with the response, send the response with the original request back to me, and then I can go ahead and answer this question. So this will work out really well. And then in the controller, we just provide it the tool or tools that it needs to answer these particular questions. So with that, I think we have what we need. Let's go ahead and dive into the IDE and write a couple of these ourselves. All right, so I am going to create a new package in here. Let's call this tools. And inside of tools, I'm going to create a new package called date time, because we're going to create a couple of these. And then in date time, I'll create a new Java class. I'll just call this date time tools. And in here, we're going to define that tool. So we're going to say at tool, and this is coming from ai.tool.annotation. And then we want to give it a good description. So we want to say get the current date and time in the user's time zone, right? And then we're going to create our method, and this is going to return a string. We'll say get current date time. And in here, we're just going to return local date time dot now, and we'll say at zone. And then we'll go ahead and locale, context, locale, context holder dot get a time zone to zone ID to string. And that should, oops, there we go. And that should give us exactly what we are looking for. So now once we have that, we're going to create a new controller. Let's go ahead and call this the date time controller, right? And this is going to be a REST controller, and we're going to get our chat client just as we have been doing. And so what we want to do in here is create an endpoint for that. Let's just call this tools, so get mapping /tools. And then we're going to create something that returns a string, because again, we're going to use the chat client and just return the content. And we're going to say, we'll call this tools. And then we're going to return the chat client dot prompt. We're going to give it a user message. What is tomorrow's date, right? Date. And then here's where we need to provide it our tools. So we say, what tools do you want to use? In this case, I'm just going to create a new instance of this. We're in Spring. You could probably just mark it with that component and then get an instance of it. But I'll just say new datetime tools. And then I'll say call Dan. And then I'll say, get me the content, the raw string there. So that's really all there is to it. Now, if you want to do this as a test, you can remove this and ask it this question. It's going to say, I don't have access to that, but I'm just going to skip that step, and we're just going to run this application. And then let's go ahead and clear this out. And we'll say 8080/tools. And with that additional context, it says tomorrow's date will be June 24th, 2025. So we're able to add that kind of information retrieval. So again, we talked about it. There's two types of tasks, or two categories of tools we might create. One is information retrieval, that is getting up-to-date information. Maybe we want to go get some like stock ticker info for the latest current stock ticker prices. Maybe we want to get the weather. Maybe we want to get some access to real-time information via like some kind of web search. This is how we can kind of handle that. The next thing I want to do is talk about taking action. So let's go ahead and put this in a new package. I'll call this action. And I'm actually just going to kind of paste some code in here, because it's not that interesting, similar to the pattern we just saw before. But let's start with the tools. So from a tool standpoint, I have this record called task result. I have an enum, so it can either be pending, in progress, completed, or canceled. I set up a concurrent hash map of tasks, and I set up a task ID generator, which is an atomic long. Then I have a task. I have an ID, a title, a description, who I should assign it to, and what the current status is. Then what I'll do is I'll create some tools. So I have a tool here that says create a new task with the title, description, and assignee. So I go in and create that task. In a real implementation, we might save this off to a database or send a notification email, but that's okay. This is just kind of step one of that. We have the ability to update a task by its ID, and then we have the ability to assign or reassign a task to a different person. So this is just kind of taking action. These are our different tools that we have available. Then from the controller, I have a REST controller here. I take in those task management tools. And so this is different, right? I'm not creating a new instance of this. This is the task management tools are a component. So they're managed by Spring, gets injected via constructor injection. I assign it here, and then I use it in the tools. So again, we're asking a message. We're going to take in a message here. We're going to use those tools and pass that in that user message. So before the tools, if I sent a message to the LLM that said, create a new task and gave it a title, description, and assignee, it would say, I don't have any functionality. I don't have the way to do that. So I need something that can augment me, that can actually handle that for me. And based on this description, it'll go, oh, you have a tool for that. I'm going to go ahead and call that. So let's see if we can rerun this. And again, what we want is the title, description, and assignee. So let's say, what was our endpoint here? So task. So we want to say HTTP 8080/task. The message is going to be create a new task with title, create tools video. Oh, let's not do that. That'll mess this up. Create tools video with a description of we need to record, edit, and publish this video and assign it to Dan. Okay, so let's go ahead and send this off to the LLM. The task create tools video has been successfully created and assigned to Dan. The task is currently in pending status. So this is really cool from an action standpoint. Now I can do a whole bunch of things that have to take an action. It's almost like a little personal assistant, right? So if I give it a workflow and it has like a certain number of steps that it needs to take, we can create all these tools to kind of chain these things together and do a whole bunch of things. So that's really interesting. So I'll go ahead and add one more in here, but I'm not going to run it. We're just going to kind of take a look at the code just to see a little bit more of an example. So this is the quintessential weather tool. All right. So I need some tools to be able to get the current weather. So here is the endpoint. This is a public API for getting current weather. We're setting the accept header and the user agent. So put your email in here. And then we have some records here that just kind of hold the data. And then we have some tools. So I can get the weather forecast for a specific latitude and longitude if I wanted to. And again, these are going to be input parameters for the LLM. So the LLM will send these input parameters back to us. I can also go ahead and get weather alerts for US state. Input is a 2-letter US state, example, California or New York. So this, we have a weather controller. And again, this is going to look pretty familiar. We get a chat client. We have an endpoint here that takes in a message, and we define the tools that it has available to us. Again, we don't want to overload these systems with hundreds of tools. In these simple examples, I have endpoints and I have a specific tool that I'm passing to it. So let's see if we can get this one to run. So I'll say HTTP 8080/weather alerts. Sure. Do you have any alerts happening in California right now? And so what I want to do here is kind of point this out that in our description, we said that this, for this tool, where is it? Get the weather forecast for a specific latitude and longitude, or sorry, this one. Get a weather alert for the US state. Input is a 2-letter US state code. So one thing that the model was able to do was look at my inquiry here and find out that, like I said, what's happening in California right now, it turned that into that 2-digit state code and sent it back. So then we went ahead and called that public API. Currently, there are 2 weather alerts in California, a coastal flood advisory and air quality alert. So we were able to get that information back. So here are a few examples. This is really just the tip of the iceberg, and I hope the wheels are starting to turn in your head, because this is where it gets really interesting. Being able to augment the LLM to get rid of some of those limitations. We can do anything with tools. We can call public APIs. We can call databases. We can call other services in our organization. Hey, how many customers do we have on SaaS product 123 right now? Right? So we could do some really, really interesting things with tools. And I hope another thing you take away from this is just how easy Spring AI makes this, right? We provide an tool annotation with a good description. We have tool params. And we have just our normal Spring code that we continue to write, and everything else is done behind the scenes. The whole song and dance of sending that along to an LLM with the tool description, the name, the schema, having it get the response back from the LLM, then kind of invoke that tool, get the response from that tool, and then send that entire request back to the LLM. If you had to do this manually, there's a lot of work involved there. And this makes it really easy to do. So that's tools. Really kind of adds to our capabilities. We'll take this another step further using Model Context Protocol, and we'll take a look at that now. All right, so now that we've had a chance to look at tools and how they can really help us augment some of these LLM limitations, we're going to kind of take the next step. And I'm sure you've probably heard of MCP at this point, Model Context Protocol. But we're going to dive into it real quick. We'll look at some theory, what it is, and we'll learn some more about it. And then we'll write a couple of different applications using Spring to build our MCP server. So I think the good place to start is why MCP. MCP helps you build agents in complex workflows on top of LLMs. LLMs frequently need to integrate with data and tools, and MCP provides a growing list of pre-built integrations that your LLM can directly plug into. So we'll look at a list of these, but if you want to integrate with something like GitHub, you don't want to build your own tools for this, right? There's already a GitHub MCP server out there. You can just plug it in and start using GitHub. So there are many, many integrations out there now, and this list is constantly growing. The flexibility to switch between LLM providers and vendors. Just because I have some client app or server app on the MCP side, maybe I have some functionality around GitHub or around whatever integration we're providing, I can easily switch out the LLM provider in that stack. We get some best practices for securing your data within your infrastructure. So there's an MCP, there are actually a couple MCP specifications out there right now for how to secure your MCP servers. And I think I have a slide on that, but I also have examples out there on how to do that. So what is MCP? At its core, MCP follows a client-server architecture where a host application can connect to multiple servers. So the MCP hosts, this is tools like Claude Desktop, an IDE, or AI tools that want to access data through the MCP protocol. You can also do this in any client like the Spring AI MCP client. So if you want to build your own client, you can. If you want to use ones out there like Claude or Cursor or Windsurf or Junie or whatever other tools are out there, you can do that. Then we have protocols like that maintain one-to-one connection with servers. So on the other side, we have servers, which are lightweight programs that expose each of the capabilities through standardized model context protocol like local data sources, your computer's files, databases, and servers that only MCP servers can access. Maybe you have remote services, external systems available over the internet, maybe through APIs that MCP servers can connect to. So this can be a combination of things. We'll look at different protocols and different servers you can build, but this is kind of the workflow, the client server architecture, where our MCP servers that we're building, any client can go ahead and kind of talk to. And I think that's an important part too, that this is language agnostic, right? MCP server A could be written in Python, server B could be written in Java and Spring, server C could be written in .NET. Like, it doesn't matter. The protocol allows any client to talk to these servers, so we can mix and match those. And we can also hand off our Java and Spring MCP servers to somebody who doesn't know Java and Spring, and they can still just use it, right? So let's talk about these transports. Transports in Model Context Protocol provide the foundation for the communication between the client and server. A transport handles the underlying mechanics on how messages are sent and received. So there is the standard input-output, and this enables communication through standard input and output streams. This is particularly useful for local integrations and command line tools. If you don't need someone else to access the server, then you can just run it locally. But if you want to go ahead and put this out there, you can use something called server sent events. This transport enables server to client streaming with HTTP post and requests for client to server communication. So those are your two options right now. There's a third option that we'll take a look at in the documentation. I think it's there, but it's not available in Spring AI yet, and it's still pretty new to Model Context Protocol in general. I talked about securing things. So if we're going to put an MCP server out there in the public and just let anybody hit it, then we need to make sure we're treating this the same way that we do any other service. We need to make sure they're secure, and only the people that can, or machines or services, only those services can access those. There is a new MCP spec out at the time of this recording, maybe a month or two ago, maybe 2 months ago, on OAuth 2 integration, and that has also since been updated again. So there's a newer spec on that, and it just talks about how to secure your MCP servers using OAuth. I actually do have an example of this out there on YouTube, so if you want to hunt for it, you can go ahead and find it. And the implementation requirements for this, you got to add Spring Security and Spring Authorization Server, configure an OAuth 2 client credentials in your application.properties, and create a server security filter chain to handle authentication and token validation. So the way this works is whatever client is requesting access to your MCP server, it will request an access token first, and then it will make the MCP request using that token, using a GET request to /SSE with the authorization header and the bearer and your token. So Spring Security Resource Server validates the incoming request, checks the access token, and then says, okay, you are an authorized MCP request. Go ahead and hit the Spring AI MCP server. There are two really good articles out there that I based my video off of. And I think we'll do another one here soon with Daniel. And these are both by my colleague Daniel. And yeah, he just talks through securing Spring AI MCP servers, and he does it in two really good steps. The first one, he kind of hard codes some credentials in there. The second one, kind of take it a little bit of a step further. So please check this out if you plan on deploying an MCP server out into the public. Now, how do we test our MCP servers? Well, when you're done with your application, you can create an executable jar. You can test it using an MCP client, like a Spring MCP client or a Claude desktop or a Cursor, Windsurf, or Junie, or any MCP client of your choice, to be quite frank. But there is one that I've been using a lot lately, and that is the MCP Inspector. And you'll find this in the documentation that we're going to go through today over on modelcontextprotocol.io. And this lets us do a bunch of things. So first, in the upper left there, you see the transport type. That's either going to be stdio or sse. You put in the command that you're going to run. In this case, I'm basically running a jar file. I connect to it, and then you'll see all of the tools available. And we're going to use this today as we go ahead and build out a simple example. And I just want to step back and make sure we kind of understand why we're doing this, right? I always need to know the why before I just start building things. And so I'm using this example of Dan Vega as a service. And so what if I wanted to build like a chatbot to kind of help me with kind of content things? So if I asked an LM right now, let's say I was in Claude Desktop, and I said, what is Dan Vega's latest video on YouTube? It is, or maybe Claude Desktop has access to search, so maybe that's not a great example. But if I just did it in a client using an LLM, it's basically going to say, I'm unable to provide real-time updates to that. And we know that now. We know that like tools are the answer for this, right? And tools allow us to get information, get access to information to augment the LLM's limitations on training data. So we could write a tool the same way that we wrote the weather tool, right? We can write a YouTube integration, and we can have a tool that has a description of, I'm able to find videos from Dan Vega's last number of videos, and maybe we just pass like a 1 there, right? So we can write a tool for that, and that's great. But what happens when we want to start adding on to that? We want to add search capability. We want to get information about Dan's newsletter or Dan's blog. So we write tools for those. Everything's working great, but what if we have other clients that want to talk to it? So what if we wrote an app in Spring, a Spring AI MCP client? What if we wanted to use it from Claude Desktop or Cursor or Junie or whatever tool that we wanted to do that in? We would have to re-implement this logic elsewhere. And so what MCP does, it allows us, through the use of tools, it allows us to encapsulate all of that logic into an MCP server. And now any client that wants to access that information can do so. And so for me, that's the way I've been thinking about tools and MCP services, MCP servers. And I think that's a good way to kind of think about it. If I'm in my organization and I write some tool, and if I believe that some other team may want access to that tool, then I'm thinking about writing an MCP server. And I'm also doing this if I'm going to use these in conjunction with one or more agents. So if I want to start to build some agentic workflows or agents that use other agents, then I want to kind of pack these up into an MCP server, and my different agents can use these. So I hope that helps. That's kind of the way that I've been thinking about this lately. So here's what we're going to build. I was at Spring I/O this year. I had a lot of fun there. I just have really great memories of it. And so we're going to build 2 different MCP servers, one using stdio, one using sse. They're both going to be pretty minimal, but they're going to teach you the basics of building an MCP server just to get some data, right? I'm going to hard code some JSON data of all the conference topics or speakers and titles and all that stuff. And we're going to do that and then build these servers so that if I ask like Claude Desktop, how many talks were at Spring I/O this year, it can look through that data and answer me. Or how many talks were given by somebody with the first name of Dan. It can go ahead and answer that. So we're going to build these 2 examples together, and this should teach you a lot of the fundamentals. Then I'll go off and show you one that I've built that is not fully fleshed out. All the things that I built for myself for tools are not like production ready or something I would hand out to someone else, but that's okay. They don't need to be if I'm not giving them to other people. Now I may want to flesh this one out a little bit more, but I write my newsletter on Beehive. And then what I have to do is my website has my last X number of posts, newsletter editions on my website. So what I have to do then is I have to go and turn this into Markdown. So what I've been doing lately, and it's not just Markdown, it's Markdown in like a specific format. If there's an image, here's where I need you to put that image. If it's a YouTube video, I use a component in my kind of view application in my Next application. I have a component for rendering a YouTube video or a blog post or a tweet. So there's like some conditional rules on how this markdown is going to look. And this used to be very manual for me, and I didn't like that. And so now what I would do is when I write it on Beehive, I just go to Claude Desktop and I pull up that project, which has a lot of notes on how I want my newsletter formatted. And I'll show you this process just to kind of help get the wheels turning. But then what I do is just say, hey, create a new post within a new newsletter post within my Dan Vega project, and based on the rules. So based on the latest draft one, like that's the one I want you to turn into an actual newsletter post. And it does all that for me. And it can, because it has access to tools like the file system, it can even write that file out for me, write the markdown for me. And it took something that was a painful process for me and made it a lot easier. And so that's what a lot of these kind of tools are helping me do. So again, not fully fleshed out, but I'll just kind of show you it working so we could see an example in Claude Desktop working. All right, so with that, that's enough theory. Let's go off and we're going to head over to the documentation. Take a little, just so you can find out where to find some of this stuff. Because again, this section of the course, MCP, we could probably talk about this for hours. But I want to make this concise. My next course that I think I want to work on is a more detailed deep dive into some of these limitations like tools or augmenting these limitations. So tools, MCP servers, things like that. But first, let's just kind of get our feet wet and learn some of the fundamentals. Okay, so if you are in the Spring AI reference and you go over to reference, there's a section on model context protocol. A lot of this I kind of covered already, so I'm not going to read anything in here. This is where you can kind of start your journey. It talks about boot starters, server starters, MCP utilities, etc. This is a really good website as well, the modelcontextprotocol.io. And this talks you through what is MCP if you want to learn more about this. Really interesting example here, or really interesting fact here, is that if you go over to the Java SDK, so Java SDK, here it is. Here's how you use it. Check out the documentation for it. This Java SDK was donated by the Spring team. So this is the official Java SDK for Model Context Protocol, maintained in collaboration with Spring AI. So that's really cool to see. But again, if you want to learn more about it, you can come over here and just read through the SDK. I don't know why it keeps taking me there, but that's okay. The other thing I wanted to point out here is if you wanted to learn about some servers. So if we go into the introduction, I believe there's some example servers. Again, you don't have to build all this functionality, which is nice. If you want to integrate with your file system or web content, fetching conversation optimized for LLM usage, memory, sequential thinking, databases, Git, GitHub, Brave Search, Slack, Google Maps, whatever the case may be, there are a bunch of servers already built. So if you want to add that existing functionality into your MCP clients, you can do so, which is really exciting. And again, this list is kind of growing and growing. So we want to build our first MCP server. And again, I think we are going to call this which one did I do? Spring IO MCP. And this is going to be a STDIO, so standard in and out. So I'm going to go over here. I don't know why that's so small. Dev.danvega. And again, we'll call this Spring IO MCP. And let's just put this in MCP. And then all I'm going to pick out of here is web. So building a web app. And I'm going to bring in the MCP. So again, you can build a client or you can build a server. In this case, we're building a server. So with that, you can go ahead and download this and open it up in your favorite IDE or text editor. Mine is going to be IntelliJ. And with that, let's go ahead and write some code. All right, so here we have the application open. If we look at the POM, we can see we are using, where are we here? Spring AI version 1.0.0. The starters we brought in are Spring Boot Starter Web and Spring AI Starter MCP Server Web MVC. So those are really the only dependencies that we need. I have my main application class. I think I renamed this because I had a previous one, but here's our main application class. And then the first thing we need to do is we need to go into application.properties. There's a few things that we want to set, especially when we're building out, well, I guess both of them, but stdio, our standard in and out, we're going to have to set some things to make this work. If you don't do this step, you are going to have some issues running your MCP server. So what we need to do is we need to say Spring main web application type equals none. We aren't actually running a web app here. We are running an MCP server. So we basically need to set this to none. I also want to go ahead and set stdio equal to true. So that is the type of MCP server that we're building. We want to go ahead and set the Spring AI MCP server .name. So I might say this is IO sessions MCP. And then you want to set the AI MCP server .description. Oh, I'm sorry, version, and then whatever this version is. So we'll just set it to 0.0.1 for now. Then we want to make sure that we disable the banner and logging for stdio transport, because if we don't do that, and yes, that is a good auto completion, thank you. If we don't do that, then what comes back from the server is not something that the MCP client can handle, because we have this extra stuff in there, the banner, the logging. We don't want that on. So again, it's very important you go through and set this up before we even build out our MCP server. Okay, so the first thing I'm going to do is set up a couple of records to kind of model our data after. So I'm going to set up a record called conference. So this is going to be a record. This is going to take the name of the conference. Let's do the year of the conference and a array of dates, a location, and a list of session called sessions, and that looks good. So then we'll need, and again, the dates could have been like a start date and an end date, like an actual date, but I'm just trying to keep this simple here. Then I need to set up a session. So let's create a new Java class called session, and this will also be a record. So the session itself is going to contain a day, a time, and again, you could get a little bit more explicit with this, but I'm just trying to keep it simple here. A title, a type. We might have an array of speakers and the room that this session was in. So that looks good. And the reason we set that up is I have some JSON data. So I went out and kind of scraped the Spring.io website for some data so that we could have all of the sessions. And again, you can pull this down from GitHub repository over on github.com/danvega, and I'll make sure the link is somewhere in the resources. So I'm going to create a new file. We're going to call this sessions.json, and I'll just paste this in. And again, just a list of all of the sessions from Spring.io. Okay. All right. So conference is still complaining? No. All right. So now what we need to do is we need to set up the tool that the MCP server is going to use. So we're building on the fact that we know what tools are. We know how to expose a tool using the @tool annotation. So we're going to do that in something called session tools. So this is going to be a class. We are going to make this a component. You'll see why in a little bit. But we'll need a couple things in here. I'm going to get a logger. I am going to set up a list of session. We'll call these sessions, and this will be a new array list. That'll initialize that. And then I'm going to get a object mapper. So this comes in with the Spring Boot Starter Web, and we'll use this in a second. So object mapper, and then we can go ahead and get that through a constructor parameter. So we have the things that we need. Now we need to build out the tool. So let's build out a tool. And one of the tools I want in here, let's say name is Spring IO sessions. So this tool, when we expose it to a client, they'll have a list of tools. It'll have a name and it'll have a description. So you know what the tool name is and what it can do. And in this case, load all of the sessions from Spring IO 2025. That's not entirely true because we can get a year, but that's okay. This is fine. So public list of session. We will call this find all sessions. And the way that we return this, we just return all of the sessions in that array list. Okay. Next, we want to load those sessions. So I'm going to do this using a post construct. So this will be private void init log.info. Loading sessions for that. That looks good. So then what I'll do is let's get an input stream. Input stream is equal to type reference dot class dot get resource as stream, and we'll get it from sessions.json. Let's close this. We are going to need an exception here. And once we do that, now what we can do is we can say, let's get the conference. So this is equal to the object mapper dot read value from our input stream. And what we'll do is we'll create a, conference dot class, right? So that should get us our conference. No, I don't want a reader. I want to read value. So I'm using the object mapper to read the value, and we get a conference back. So then we can say this dot sessions, if we could spell right, Dan, is equal to conference dot sessions. Okay, and then maybe we want to catch this instead of, so let's say IO exception, E. Okay. Let's just say I don't need this. But I feel like there's that. And then we need one more here. Okay. So when this component gets loaded, the init method runs. We're loading all the sessions. We're trying to read them from that JSON file. And if we can, we'll get the conference object. And from the conference object, we can get all the sessions. And then just set it to this array list. And that is what is going to be returned when we call this tool. Okay, so there's one more kind of thing we have to do from an MCP server perspective. We need to somehow tell the client that is talking to this server what tools are available. And you can do this in a configuration class by creating a bean. And the bean is going to return a list of tool callbacks, right? And we'll just call this Spring IO session tools, right? And this will take in our Spring session tools, that class, that component that we just made. So session tools. And the way that we can do this is, there are a few ways to do this, but one easy way is to just say, let's return a list, and we can use the tool callback dot from, and that from will take, let's jump into that. So from takes an object of sources, instances for tools defined in different sources are not defined here. And in this case, they're defined in this session tools component, right? So that will return back a list of them. Now, if you had multiple components with multiple tools, you could just create a list of the different tool callbacks. So that's all we need. We have a tool defined and we return a list of tool callbacks so that when the MCP server is invoked, that functionality, when we kind of run a client against that server, it'll say, here's all the tools that are available to me based on this. In this case, there's just session tools and a single tool named Spring IO sessions, all right? So from a code perspective, I think we are good to go. Now, what we want to do is we want to go ahead and create an executable jar. Not right now. So what we want to do is we want to just run mvmw clean package. And then we should see a target folder with our Spring IO MCP Studio stdio 0.0.1 snapshot.jar. You could even go ahead and copy this because we'll need this, the full path to that. And with that, we are ready to go. We are ready to test it. Now, you could test it in different clients. I told you about the MCP inspector. I'm going to use that. So if you head over to modelcontextprotocol.io under tutorials and inspector, you'll see how to run the MCP inspector. So you can just say this. You can give it a command and some arguments, but I'll just go ahead and run this. And then it will, so this is kind of new. I've just seen this the last few times. There's a session token. It won't run without it, but you can use open the inspector with the pre-filled token. So this will open the MCP inspector, and now we can start to test this out. So we got to choose our transport type. I mentioned stdio, SSE. There's also streamable HTTP, but we are building out an stdio. This is, we got to go back. I got to copy that. So, oops. Come on, Dan. All right, copy, and then go back here. I'm going to paste this in the command here. I'm basically running, I'm basically running java-jar against that full path I just gave it. And then I can go ahead and connect to it, and it'll start to list things out. Now, we haven't gotten into the full kind of MCP protocol spec. You can do things like resources and prompts, but all we're worried about right now is tools. So if we go over to the tools section, you can say list tools. And when I click this, it's actually asking the server what tools are available. And that's where that bean came in with that list of tool callbacks. And so now it says, hey, you have a tool called Spring IO Sessions, and here's the description. So if we click on that, it'll come over here, and then we can go ahead and run that tool, and you see that it basically returns all of those sessions. Now, this is just kind of testing this out. The next step that you want to do is maybe run this in a client like Claude Desktop or something like that. And with this tool configured, you can now ask questions about Spring IO Conference because it has this tool enabled. All right, so then if you go up to developer here in Claude Desktop, you can do a bunch of things. MCP configuration, you can reload this. You can open the config. You can also go over to settings, and under developer, you can see the different MCP tools that you have enabled and a way to edit the config. So the config, let's go ahead and open this in maybe VS Code. And you'll see this is just a JSON config file with MCP servers. These are the different servers that I have basically installed. And so if you look for public servers, you'll find like this is something you can just copy and paste into here. In this case, I'm giving it access to my file system in these locations. Here's the Spring IO Sessions one. So here I'm saying, here's the command you're going to run. You're going to run Java. I don't know why I have to fully qualify this path. I don't feel like I had to do that before, but I am doing that now. So I'm saying run Java. The arguments are -jar. And then here is the file that you want to use. So again, let me go back here and copy this and go back here just because I think that's a different one that I was using. And I'll save that. And then once I close this, I can go to developer, reload MCP configuration. So now if I go in here, I should see some tools that I have available to me. So I have some built-in tools into Claude Desktop, like being able to search Google Drive or Gmail or Calendar. These are the ones I've defined in that file, one of which is Spring IO Sessions. And you can see it has just a single tool available. If we had like 10 tools, those would all be listed here. So now I can start to ask questions that previously Claude could not answer. But now, because we've given it a tool, it should be able to answer this. So how many total sessions were at Spring IO in 2025? So it sees that it would like to use an external integration. Yes, we're going to always allow this. Now it has access to that tool. It got a response from that tool. Based on that, now it's going to run some code to figure that out. So it says, okay, here's the data. Now I can go ahead and do a calculation. You running some code, I can calculate how many talks were at this conference. And hopefully at the end of this, it will give us a result. So Spring IO 2025 had a total of 80 sessions. Here's the breakdown. We even get some things I wouldn't have considered by session type, workshops, breaks, logistics, opening, keynote, networking, celebration, closing. By day, on the first day there were 37, on the second day there were 43. Rich program with 68 content sessions, talks, and workshops, plus various logistical and social activities spread across 2 days. So that was it. We built an MCP server that exposed some data that we can now have conversations with and get some insights into some of that data that we provided. So that was the STDIO. Let's go ahead and now talk about how we can not convert that. Let's start new and build an MCP server that uses server-sent events. So we can put this out in the world. Now anybody can use our MCP server instead of having to like run it locally. All right, now that we've built the STDIO version of this MCP server, I was gonna walk through from start to finish how to build the SSE version. I thought better of it. This course is getting kind of long already, so I wanna trim that a little bit down. It's the same code minus the configuration. So we're just gonna adjust the existing project that we just worked on. If you want to see the full project, there's some other things in here too. github.com/danvega, Spring IO MCP SSE. That's where the full code is. If we go back to the existing project that we have, all of this is going to stay the same code. It's just different properties that we need to set to get this to work. So what I'm going to do is I'm actually going to rename this because I have this as a YAML file in the project. And what we'll do is we'll just copy this code over and take a look at it because me typing it out is not the interesting part. So we're going to set a few different things here. From the Spring AI MCP server, we have our name, we have our version like we did before. We enable it true. Type, which is sync. Here's basically our description. And then we are setting some capabilities. So because we didn't say that STDIO is enabled or true, then this is now an SSE version of that. And then when we do that, we also have some capabilities like I mentioned this before, there are other capabilities we can make available from our MCP servers. We can set prompt templates, we can provide resources, we could provide tools, completions. All we're really doing here is setting a tool. So in fact, I can turn this one off. In the version online in GitHub, I actually set up a resource. So you can see how to do that as well. But this sets us up. Now, this is going to be in a web app. So this will be running. So we need to serve it on a port. So I'm going to serve it on port 8085, just so it's different. We set up some management endpoints. I was including these because I was doing some debugging, but you could probably take this out as well. And then I set some logging. Again, not as important on the STDIO version where it's pulling back that information. We can kind of log some stuff out here because this is a server running separately, right? So let's see if we can get this to work. So all we did here was change this. We still have our application, our conference, our session, and then our session tools, which is just a component making these available. So let's see if we can go ahead and run this. And we see that it is started on 8080. So now what I need to do to test this is to use the inspector again. So let's go over there and I'll go ahead and load that up. Now, instead of the transport type being stdio, we're going to choose server send events. Now it's going to be looking for where is that running. So that is going to be at 8085/SSE. So let's go ahead and try to connect to it. Again, we see tools. Let's go ahead and list our tools. And now we see the Spring Session tools. We can go ahead and run that and we can get a list of our tools. So now our server is running localhost 8085/SSE. So that works. So again, building the MCP server is the same. It's just a configuration on whether you want it to run locally or maybe you want to run a server. So now we could go ahead and deploy this somewhere, and then any client from any place in the world can go ahead and connect to it and use that as an MCP server. Again, I mentioned this in the beginning when we started talking about MCP. Now security becomes important, right? If you're running a server out there and you don't want everyone to have access to it, we need to start thinking about security. I gave you some links to some great articles by Daniel Garnier that talks about securing your MCP servers with OAuth, and that is an important part of this. Now, I want to take a look at something else. Let's go ahead and get rid of this. Actually, we'll jump over here. So we looked at Claude Desktop as a way to connect to our stdio MCP server. It turns out that not all desktop or not all clients support stdios. A lot of them, you need to have a server running. But I just want to show a different client connecting to our MCP server, in this case, an SSE version of it. So I'm going to use Claude Code. Claude Code is this nice little terminal agent. So you can basically spin up an agent in a terminal and have it help you. The nice thing about this is it has like context to your application. So it can, like, in the context of all of your code, it can act on that and use that as context for what it needs to do. We're not going to really look at that today, but I'm just going to show you how we can add it to Claude Code. So you can add it for stdio, or you can do an MCP SSE server. So you just say Claude MCP add transport is SSE, the name, and then the URL. And here's an example of that. So let's go ahead and kill this. And what we'll do is we'll just say Claude MCP list. There is one in there already. So let's say this is a stdio version. So let's list, how do we remove those? Claude remove Spring IO sessions. Yes. I don't think, oh, I think I missed. Here, let's go back. Did I miss MCP? Yes. So I need to do Claude MCP, remove that one. Claude MCP list. Come on, Dan. Okay, so we have no servers. So now we can say Claude MCP add transport is SSE. The name is Spring IO sessions, and it is running on HTTP localhost 8085. Did I spell that wrong too? I did. I'm just having an off day here. Not really. This always happens to me. Okay, so now we've added it. So now we can say Claude MCP list, and there is our MCP server running. All right, so now I'm just going to run Claude, and I say yes. Ooh, and we get an error down there. MCP server failed to connect. let's just see what is going on. This is localhost 8085, right? Yes, 8085. Oh, we probably want to change that. Let's say Claude MCP, remove Spring IO sessions. We want Claude MCP add transport SSE Spring IO sessions. We want it at localhost 8085/SSE. All right, now let's go ahead and try this. All right, now we can say how many sessions were there at Spring IO 2025 that covered AI. You see it, I checked the Spring IO 2020 session to find out how many covered AI topics. And then I went through there. Looking through there, I can identify these, and it's a 10 sessions covered AI topics at Spring IO, including Code Smarter, Not Harder, AI-powered data hacks for all, from yours truly, Dan Vega. Again, we can integrate MCP services in all types of different clients, Cloud Desktop, Cloud Code. On the OpenAI side, they have Codex. Again, whatever client can support MCP, we can add that functionality into our daily workflows. So that's really kind of what I wanted to show off here. All right, I thought I'd show you an example of a real-world MCP server that I put together for my newsletter. So I use this app called Beehive, and it allows me to kind of create newsletters in different publications. So I have my Dan Vega publication, and then I have a bite-sized AI newsletter. And inside here, you can create posts, you can like create your audience, you can go through and filter them out. There's ways to monetize, there's ways to get analytics. Essentially, it's a way to a whole bunch of really great features around building newsletters. So I wanted to put together an MCP server for one specific use case. In the bite-sized AI newsletter, I just write that newsletter on here and I publish to the web and to the email. On Dan Vega's, I create a post and I write in Beehive because I like that writing experience. And then when I send it, I actually send it to my email list, but I publish it to my personal website. So if I go over to my website, you can see on newsletter. I want to find a good example here, maybe this one. So I only published like the last 5 on my website. Obviously, if you dig through the source code, you can find it. But here on the website, if I go look at this, this is taken from the Beehive authoring experience and then turned into specific Markdown. So I run my website on Vue and Nuxt, and I have some Markdown here, and that's how this is displayed. So 1, I got to turn it into Markdown. But 2, I also need to use special Markdown. So like for a YouTube embed, for another YouTube embed, if I have, let's go back a couple here. So there's some more YouTube videos. There's an image. There's a tweet. So I have a Twitter embed as well. So there's a whole lot of things like special use cases that I got to handle for. And this before was very much a manual process. I would publish it here, and then I don't even remember what I was doing, but it was not fun. A manual process of creating that Markdown. So what I've done since is create a project in Cloud Code that has all my formatting instructions. And then I created a Beehive MCP server because what I needed to do when I'm in Claude Desktop, I will say, go grab me the latest blog post that's in draft. It'll grab that. And then based on my project, it will go ahead and write out the correct Markdown that I need to publish. Then I took it even a step further. You can use something like the file system MCP server and have it write the file out for you. So this is the project. I have this open here. Let's go ahead and So I have a bunch of tools that we load up for things like post and publication and subscription. So if I go to post, I have a post service. We have a REST client that we inject here. And then I have different tools for like get all of the posts, get a single post. And I'll actually show you this in action. But the other thing we do here is I've set it up so that we build some native images. So let's go up here. So you can, if you have Java, you can go ahead and build a just an Uber jar and then run that from whatever MCP client you're using. But I also have a way to build native binaries. So if you want to run this on macOS without Java, you can do that as well. So check the project out, start if you'd like, but let's go ahead and kind of see this in action. So what I'm going to do is I'm going to open up Claude. I've already installed this. If we go ahead and look at the tools, we can see Beehive here. We can see we can do a whole bunch of things, right? So publications are the top level publications, Dan Vega or Beehive, and then posts, we can get posts for each. So let's just start out and say how many publications do I currently have on Beehive? All right. And then what that's going to do, it's going to realize it has tools to answer that question. So it's going to go ahead and ask for permission. Actually, I've already given it permission, and I don't think I've shut it down. So there you go. You currently have 2 publications, Dan Vega and Bite-Sized AI. Great. Can you give me the last 3 posts for each? So the way this works too is underneath the hood, when you configure the Beehive MCP server, you can optionally enter a publication ID, and that will kind of be the default. But I wanted to make it extensible, so everything that like posts takes a Beehive or takes a publication ID. If you pass one, now we can do this for both. So you can see there were 2 calls basically. For each publication, it went out and got the last 3 newsletters. So we can see that. This is cool. All right. So far, so good. So let's take it one step further, and let's say from the Bite-Sized AI newsletter, can you give me all of the posts that have a content tag of OpenAI? And so really kind of what this is hopefully showing off is that there are a whole bunch of things in here for filtering out all the different types of posts. So in this case, yep, we have 3 total ones. Here's the description, tags. So we see the tags for those. And just, I think really cool. Again, just kind of scratching an own itch. I write this newsletter. I need an easy way to kind of go through and create my newsletter on my website. And so being able to hook into the Beehive API and create an MCP server. And the reason I do that is because I want generative AI to look at my rules, take that HTML or whatever that content is from Beehive, and then write out that specific markdown for me. And then go ahead and write a file for me. So I just thought a pretty cool use case of an MCP server that I built that you might be interested in checking out. And with that, I think we're done with MCP. And let's go ahead and move on to the next section. All right, so everything that we've done up until this point has been done with a proprietary model. Things like OpenAI's GPT, Anthropic's Claude, Google Gemini. These are all models that take tens of millions and millions of dollars. I don't even know how much, probably hundreds of millions of dollars actually, to train, to pre-train, to get everything right and get out there. And so these models cost money. So let's talk about open source versus proprietary models. And in this section, we'll go through some of the benefits. We'll talk about how to run them with some tools like Ollama and Docker and Hugging Face. And then we'll show you how to use those models in a Spring AI application. So before we go into the pros and cons of open source models, I want to talk about what it means to be an open source model. When someone says an AI model is open source, it means more than just free to use. We borrow this software open source definition. Anyone can run, study, modify, and share all the artifacts under an OSI approved license. So what does that mean for models? Well, we have weights. These are the parameters that they're trained on. We learned about this earlier. We have source code for data processing, training, and inference. We also have the training data set or the manifest so others can reproduce or audit it. So some just share their parameters. These are called open weight models, maybe not open source models. Meta's Ollama license is a really good example of this. The weights are public, but the no use of outputs to train another model clause violates the OSI definition. So Llama 3 is open weight, but not open source. So if you ever hear open weight versus open source, that's kind of what's going on there. So let's talk about some key challenges. So open source models like Llama 3 or Mistral Small now hit GPT 3.5 class scores, but they still trail some of the very top closed systems by roughly a year in reasoning and multimodal tasks. The gap may narrow, but today you must decide if close enough is good enough for your use case. You own the GPUs or the cloud bill, plus the stack to serve, scale, patch, and monitor. A single 70 billion parameter model can require greater than 40 gigabytes of VRAM. Fine for a demo on an M series Mac, but costly in production without quantization or sharding. You basically have no vendor grade support. There is community issues and PRs move fast, but offer best effort fixes and not the 99% uptime guarantees that the enterprises expect. Safety and quality risks. Open models are trained on broad, sometimes undisclosed hallucinations, biased outputs, and policy non-compliance can slip through. You must bolt on your own content filters and red team tests. So security is a big one. Public weights can be poisoned or backdoored before you pull them. Public Docker images can ship with outdated dependencies. Security reviews, SBOMs, and reproducible build checks become your responsibility. From a license and IP standpoint, not every open model is Apache 2.0. Many are source available with non-commercial or usage-based clauses. Accidentally violating a license can derail commercial plans or trigger retraining cost. When dozens of new checkpoints land weekly, you must run your own eval harness or trust shaky leaderboard claims to see which model truly meets latency, cost, and accuracy targets for your domain. And finally, rapid fire releases really gives you some kind of maintenance churn. The community iterates monthly, keeping things like weights and tokenizers up to date, but you must do this across CI and prod, which means your CI pipelines and model registries need constant updates. So that was a little bit of some challenges, but why would we reach for open source models? So first off, transparency and auditability. Open source weights and code let your security team inspect what model knows and how it produces the answers. That matters when you're embedding an LLM in a regulated workflow or need to prove that no hidden prompt leakage is possible. Self-hosting for data privacy and compliance, and this is really a big one. Running the model inside your VPC or even locally on a developer laptop with tools like Ollama means sensitive customer data never leaves that controlled environment. This makes for PCI, HIPAA, GDPR aligned architectures far simpler than routing every call to an external SaaS point. Lower total costs. There are no per token costs or monthly fees. You only pay for the infrastructure you already understand And for bursty workloads, something like nightly batch generations, you can always scale those down to 0 and avoid that idle billing you get from the proprietary models. Low latency local development. When you run the model right on your laptop, every token is generated over localhost rather than a round trip to a cloud endpoint. This gives you that snappier feedback loop. It works offline. You get consistent behavior from it. Because the license often allows derivative works, you can fine-tune your own domain, change the model architecture, patch the tokenizer or system prompt without hitting API costs. So some cool things there. The open source community iterates fast. When a bug or jailbreak is discovered, someone ships a fix, usually the same day. You benefit from thousands of researchers without waiting for a vendor's next release cycle. Do you want a GPU on AWS today? Switch to an on-prem GPU tomorrow, then compile to WebAssembly for edge inference next month. The same model weights can move with you. So this gives you a really nice feature there. And no vendor lock-in. The API terms, pricing, or rate limits can change overnight. With open source, you own both the model artifact and the infra, so migration is a Helm upgrade, not a 6-month reintegration project. This future-proofs the Java services that we'll kind of demo throughout. So how to evaluate open source models? Well, you can start with license and openness. Is it OSI approved? Are there any commercial use limits? These are some things to look at. What are the benchmarks? Check neutral benchmarks like the Hugging Face OpenLLM leaderboard. There are a bunch of other really great leaderboards out there. You can check those for kind of benchmarks. Tool calling. If you plan to use agent workflows and the tools, the things that we talked about today so far, you want to pick a model that's already fine-tuned for function and tool use. So I'll show you when we're selecting a model over on something like Ollama, there is a way to find out which ones have tools. Parameter count drives cost. So a 70 billion parameter may need greater than 40 gigabytes, while 7 billion parameter runs on a MacBook GPU. So that's really nice. Context window matters, right? If you're going to shove a 400-page PDF into RAG, look for extended context variants. Things like Quinn 2.5 offers 128,000 and even experimental 1 million token windows, handy if you can't stream chunk easily. Latency and throughput. Run some quick load tests. Use your load test generators and find out which one of these models that you're evaluating meet the latency and throughput requirements that you're looking for. Look at GitHub, open pull requests, issue response time, recent commits. So these are things that you want to check out. When was the last kind of commit to some of these local models that you're going to evaluate. Security and supply chain. Verify the hash of a wait file. Prefer images with SBOMs and run dependency scanners. Poison checkpoints have appeared on public hubs. So this is also something you can do. Okay, so getting to where you can get some of these open source models. So Ollama is one, ollama.com. You can go in and search for models. We'll do that as we get into the demo. Another one is Docker Model Runner. So if you're running Docker Desktop, this one says for Mac with Silicon, but this also works on Windows now. So if you're running Docker, you can easily pull down open source models and then go ahead and use them in the terminal. So I can just run that model and start interacting with it. If you are not a terminal person and you want a familiar UI that you're used to using, something like ChatGPT, right? There are some really good projects out there, one of which is Open Web UI. So you can run this and then it'll look at what models you have installed locally. You can pick between them and then go ahead and use a familiar chat interface. There's another project called the LM Studio, which is the VS Code of local LLMs. Perfect for rapid prompt R&D before you wire the same weights into something like Spring AI. It's cross-platform for macOS, Windows, and Linux. You get a one-click download for your models, built-in prompt playground with temperature and top P sliders. This is something similar to Google's AI Studio that I showed off already. And then it optionally exposes an OpenAI compatible REST endpoint. This means that we can pull this into something like Spring AI. Hugging Face is your app store for models. Use it to find, fine-tune, and ship whichever LLM fits you best in your Spring workloads. So what problem does this solve? I don't want to run a 15 gigabyte model on my laptop, but legal says I still can't call GPT-4o. So from the Hub UI, you can click deploy to an inference endpoint. You can choose cloud like AWS, Azure, or GCP, and your region. Hugging Face spins up a dedicated VM or container with the model weights. Flip the private toggle to create an endpoint that is reachable only through the VPC or AWS private links, so there is no public IP. So all of these really great options. We're going to take a look at a couple today. We'll go through a demo of how to go ahead and pick a model, run it on your local machine, how to interact with it, and then how to use it in your Spring AI applications. All right, so we'll start with Ollama. You can head over to ollama.com. You can go ahead and download it for Mac OS, Linux, and Windows. So follow the download instructions there. Once you have it downloaded, you can go ahead and look for models. So I go over to the models and I can see all of the models that are available to me. And if you go on to a specific model, so let's say Quinn 3, you can see all of the different models that they have. So these are the sizes. Now this is going to be very important if we're installing it on our local machine here, because 142 gigabytes, probably not going to be able to run, but something small like the 5.2 gigabyte model with a 40K context should be able to run okay. And then you can learn more about it here. So you can also go into, I think it shows you some benchmarks. Here's the different models. I believe there's somewhere that you can find which ones. Oh yeah, so tools. So it has tool support and thinking support. So let's go ahead and try and run this one. So I'm going to copy this. And then what I'm going to do is open up a terminal. And from a terminal, I'll go ahead and run Ollama, and you can run help to see what commands are available. So the first one in there is list models. Let's see if we have any models downloaded here. And I actually do. I have Gemma downloaded, so I can use that. If I wanted to run another model, I can say Ollama, and I can say pull, and then I could paste in that particular model that I wanted to pull. I'm not going to do this because then I'll just have to wait a couple minutes and then fast forward this. I'll just use the Gemma one that I have installed. So once you have one installed, you can say Ollama run and then the name of the model. So in this case, Gemma 3, and it will go ahead and get you into an interactive shell here. So now we can send some messages. So I might say something like, tell me an interesting fact about Java. And you could see right away, very fast, because again, we don't have that latency. So we get that immediate feedback. Now, this may vary depending on your machine, but for me, this is very quick. So again, we go back to the pros of this. I'm not paying for this. Really quick to use, secure. If I end up using some of my own proprietary documentation that I don't want some of the big frontier models training on, this will work out well. So this is a good start. We're able to use this Gemma 3 in an interactive shell. All right, as I said before, this is using that terminal to kind of interact with it. If you want a more familiar chat environment, this is one of the projects that you can reach for. So this is the Open Web UI. There's an easy quick start with Docker. So if you're running Docker Desktop, you can simply paste this command in, and I think that's what we'll go ahead and do. So let's say exit out of here, bye. All right, so let's go ahead and paste this in. Do we not have Docker running? Probably not. There we go. Let's try that again. Oh, already in use. So let's go ahead and bring up our Docker desktop and look at our containers. There is our Open Web UI. It is definitely running. So now we should be able to just go ahead and open this up. And we see that we get this nice kind of chat interface. So we see what models are available. I'm going to use that Gemma 3 model. And let's ask it to write some code. So write me a simple Java program that takes in someone's name and prints it to the console. Okay. So again, that low latency, very fast. We have these nice formatted code blocks. We have our explanation, how to run it. So real nice experience here with Open Web UI if you don't want to use that kind of terminal-based experience. All right, so another option is Docker Model Runner. This was originally just for Mac with Apple Silicon, but has since branched out to Windows with NVIDIA GPUs. You can read through the documentation here, kind of how it works. Again, you do need Docker Desktop to get this up and running. You can publish a model. And then what happens from this is you can expose some API endpoints. So if you click on this and expose these API endpoints, you can now go from a host process like localhost 12434. And this is OpenAI compatible. So when I go to start.spring.io, I pick OpenAI, and then I just point the base URL to this instead of OpenAI. And now I'm using my local model instead of something like OpenAI. And you can use it in Spring AI just like you would OpenAI. So this is a really good option. And this has since changed since I've done a video on it. Now it's kind of integrated into here. You used to have to go through the command line to pull models. But now you can see I can list all my models here. I can go to Docker Hub and search for different models and then go ahead and pull them right from the UI. So this is really nice. So again, once the model is running, once you pull it down, you could interact with it on a command line. You just use the Docker Model Runner command line tool to run these models. But what we want to make sure that we do is we want to go into our settings. And you'll want to go into beta features here and enable Docker Model Runner. And you want to click this if it's not clicked, enable host side TCP support. So now we have that available on a port. This allows us to go ahead and have that URL that we can kind of configure in our Spring applications. So that's Ollama, that's Docker Model Runner. There's also Hugging Face, LM Studio. There's a lot of things we can do to run open source models here on our local machine. And these things make it really easy to do. So now that we know how to run them on our local machine and kind of interact with them from the terminal or from a chat UI, let's talk about how we can go ahead and use these local models like the one I'm running here, which is Gemma 3 from Google. Let's see how we can use this in our application. All right, so here we are on start.spring.io. We're going to fill in some metadata here. Well, actually, before that, let's look at this. So depending on which version you use, if you use Ollama, you can come in here and just pick Ollama. So I would pick a web project, I'd pick Ollama, and just like we did in the very first example with OpenAI, you can do the same thing here. You just go into Ollama, and then you configure which model you're going to use. So in this case, it would be Gemma 3, and you're off and running. If you want to use something like Docker Model Runner, again, it has an OpenAI compatible API. So we would just choose something like that. So I'm going to fill this out, dev.danvega. We'll say Docker Model Runner. And that looks good. And that's it. We're going to generate this project and open this up in our IDE. Okay, so with our application open, the first thing we need to do is to go into our application.properties. So we are using that OpenAI API. So I'm going to say spring.ai.openai. And the first thing we need to set is our API key. If you don't set something here, Spring AI will complain because you need an API key for OpenAI. But in this case, we don't need anything. So I'll just fill in something here just so that it doesn't complain. So then next, what we want to do is we want to set the chat base URL to something else. So in this case, it's going to be localhost 123, what was it? 12434, I think it was, yeah. And this will be engines llama.py client.cpp. And again, this was in the documentation. That's how I found that there. Finally, we'll want to set the model. So from the model, I'll say this is AI Gemma 3. So with those in place, we've now configured our Spring AI application to talk to our local model. Because of that, I can just come into the application here, create a simple bean that does something. So let's say we wanted to create a command line runner, and we can get our chat client.builder, and return args. Yes. All right. So now that we do that, we can get our chat client. So we can say client is equal to builder.build. And we can go ahead and use that client to send a prompt. I'll send a user command, a user request here. And I'll just say, when was Docker created? All right. And again, we'll just make a call. This is a blocking call. And then we'll just get the content back. And I'll call that response. With that, we can go ahead and print out the response. And we should be able to run this. And this will take a second, but then we should get back a response from the model here. Great. So here it says Docker was officially created in July of 2013. Here's a breakdown of the key milestones: early concepts, public release. That is our answer that we got from our local model that is running on our machine. So again, really cool. We get a whole bunch of benefits out of this. We get fast response times, low latency, right? No latency. We get the security. So if we're going to do things like RAG, we are not going to be sending our proprietary documents out to the frontier models. We are not paying for this. For me, this is a really good place to start. If you want to start MVPing something and you don't want to sign up for one of the kind of big proprietary models and pay for it, that's okay. You can use one of these local models if you have a powerful enough machine. So I think that's it. I just wanted to really quickly cover what open source models are, how to kind of run them on your local machine, and how to use them in Spring AI. So with that, let's move on to the next section. When your AI application starts returning bizarre results at 3 a.m., you need to know why, and fast. Building with Spring AI means orchestrating LLMs, vector stores, embeddings, and external APIs, each with unique failure modes and cost implications. Without observability, debugging becomes guesswork. Traditional monitoring isn't enough. Beyond tracking latency and errors, you need visibility into your token usage, prompt performance, embedded generation, and RAG retrieval quality. You need to understand not just if something failed, but why. In this section, we'll explore Spring AI's built-in observability features with micrometer and open telemetry. You'll learn how to track the metrics that matter, trace requests through your AI pipeline, and build dashboards that provide real-time insights. Because in production, hope is not a strategy. So we're going to talk about Spring Boot observability. Now, the observability story in Spring Boot has changed. In Spring Boot 3.0, observability was kind of rewritten from the ground up, starting at the framework level, and then most of all, being able to expose the same API that the framework uses to our application so that we can use them as well. And throughout the 3.x line, there have been a lot of improvements with observability. And then we've also seen that span out to the different projects. And Spring AI is no different. Spring AI takes advantage of the observability in Spring Boot, and we can get some interesting metrics out of it that will really help us when we get these projects into production. So the actuator dependency, it is the dependency that I think you should include in every single project. Even if you don't think you're going to use it, at some point you will. And this is the dependency that we need so that we can start collecting those metrics using Spring's built-in observability. Okay, so the real question is, why observability? I think from an AI perspective, these three things really stand out to me. Cost can really spike. Again, just doing this on your local machine, not a big deal. But if we put this into production with high throughput, we need to understand the tokens that are going through our system, whether it's input, whether it's a user input or a response from an LLM. And we need metrics on this. How many tokens on average, input and output, total tokens, tokens per request. Those kind of metrics are very important. With some of those pricing metrics that we saw earlier, this is very important. LLMs are non-deterministic. So we could ask the same thing 5 times and get 5 different responses. We really want to have some traces and logs for debugging that, seeing what types of responses we're getting, making sure that things are safe. And again, on number 3 here, safety and legal. We need evidence when things go wrong. If some kind of really biased or harmful answer comes out, we need evidence to show that that happened. So what is observability? For us, the 3+1 pillars of observability: metrics, logs, and traces. Metrics are the latency, the token counts, the cost, etc. Logs are, hey, I want to get structured prompts, responses. I also want personal identifiable information redacted from that. Traces, end-to-end view of our RAG pipelines, how those things are working. And then the +1 for AI is evaluations, automated quality checks. We'll talk about this in the next section. We'll take a look at how to write some tests, especially on the non-deterministic side of things. So what does Spring give you? We get some micrometer metric names out of the box, like our GenAI usage, our latency. If you want to learn more about what metrics are exposed, check out the docs at spring.io. Observation events, so we get micrometer tracing, open telemetry. We get pluggable log masking, so again, to hide some of that personal identifiable information. And then a generation listener hook for custom metrics. So that's all I really wanted to cover, just a quick intro to what observability is. I think what we'll do now is we'll take a look at building an example together that uses something like Grafana and Prometheus to collect those metrics and expose them, and then build out some dashboards with them. So with that, let's head over to start.spring.io. All right, so I'm going to fill out some metadata here. We'll call this dev.danvega, metrics. We'll use JDK24, and then I'm just going to start building this out. We're going to build a web application. We're going to use OpenAI as we have been doing so far. We want to get those metrics, so I want to bring in the Spring Boot actuator. I want to bring in the Docker Compose support. We are going to be using Docker Desktop here. If you don't want to use Docker, you can stand up a Grafana instance, stand up a Prometheus instance, and that will work fine. This is easier for me because now you can just pull down the entire project from GitHub and run it if you have Docker Desktop running. So because we have the Docker Compose starter there, I'm going to go ahead and reach out for a couple other things. So I'm going to go ahead and add Prometheus, and then let's just go ahead and look at this. So we do have that Docker Compose, and when we have AI, we also get this Spring AI Spring Boot Docker Compose starter. Now we'll have to add Grafana manually, but that's okay. I think this gives us everything we need. So with that, let's go ahead and generate this project and open it up in our IDE. I just realized one more thing that I wanted to kind of show you before we jump into the code here is we have the Spring AI metrics project over on GitHub. This is linked in the main workshop repo. So if you look into the observability package, you'll find a link to this. And this has some good information on how this project is structured. We're going to go through some similar things. We're going to write some things ourselves. I'll also probably copy over some of these like configuration files. We don't need to do those together. But more importantly, it kind of tells you like how this stuff kind of works together. So the Spring Boot actuator, what it does, it adds monitoring capabilities to your Spring Boot application, key features, it exposes health metrics and application information as HTTP endpoints, provides data about memory usage, thread counts, etc., allows you to check if your application is up and functioning properly. Now the Prometheus option dependency that we selected from the Spring Boot initializer is what it does. It collects and stores metrics from your application as time series data. So the key features here, it scrapes the metrics exposed by the actuator at regular intervals. So without this, you wouldn't have anywhere that kind of stores this data. The actuator just exposes it. So it stores this efficiently. It provides a query language that you can analyze these collected metrics on, and then includes alerting capabilities. And then finally, once we have these metrics, Grafana, what it does is visualize the metrics stored in Prometheus through dashboards. Instead of having to just kind of query this stuff and look at all this data, you can create customizable dashboards with graphs, charts, and alerts. Connects right to Prometheus as a data source, supports annotations and templating for dynamic dashboards, and again, provides alerting based on metrics thresholds. So here's a little diagram of how it gets put together, and then you can run this example if you want. But I just wanted to show you, this is the example that we're going to build out together. All right, so here I am in the application. The first thing we're going to do is open up this compose.yaml. I thought I would have at least a Prometheus in there, but that's okay. We're going to copy from that project that I just mentioned and walk through this. So first we have Prometheus. We have the latest Prometheus. Here's the container name. We're going to have a volume here. So this is going to be in /docker prometheus.yaml. And so again, I'm going to copy these configuration files from that project because we don't need to walk through them line by line. Here's Prometheus. It just gives it a name, where the metrics it's scraping from. So it actually wants to pull from the actuator Prometheus endpoint. And then where's the target? Then we have Grafana for building out the dashboard. So this is going to run on 3000. Oh yeah, this is on 9090. And then we have some volumes here. This is Grafana provisioning, and then Grafana dashboards. So in the dashboards, we have a sample AI metrics dashboard. You can build these out by yourself. You'll see once we get into Grafana, you can like build them out kind of WYSIWYG style. You can build out charts and graphs and what metrics you want to see. And then what you can do is kind of export this out. Another pro tip here is AI is pretty well trained on Grafana. So because this is, we can use this in like a JSON format, you can ask for to generate some like generic dashboards just to get an idea of what you want to kind of build there. So those are the configuration. We also have admin as the Grafana username and password. Okay, so that is the Docker Compose. I don't think we need anything else there, right? Let's make sure we have registry Prometheus and the actuator. Okay, so those things are done. Okay, the next thing that we'll want to do is we need to set some properties, right? So let's go into resources, application.properties, and let's just paste in a couple things. So here's our OpenAI configuration. We saw this before. We're setting our API key, the model that we want to use. From the actuator and configuration, I'm just exposing what we need, our Prometheus, our health, and an info. I don't want to expose everything. And then Prometheus metrics export enabled equals true. Setting some configuration on the histogram all, setting that to true. Again, we're just trying to collect a lot of data here. Some of these things I might change when we get into production, but right now, just trying to set this up. We have our export step, so every 5 seconds. Our micrometer tracing for exemplars, like how many do we want to do this on every single request? So 0.0 is no requests, 1.0 is all requests. Again, for kind of development, I want to see that enabled on every request I just want to start to collect on. So that's our configuration. After those two things, we are pretty good. Now we can just build an AI application, send some requests to it, and then hopefully see that in our Grafana dashboard. And actually, we'll go into Prometheus and see it there first. Again, Prometheus is the data source for our Grafana dashboard. So let's go ahead and create just a simple chat controller here. This is going to be a REST controller. And I'm going to create a couple of different ones. So let's say get mapping for short, something short, public string short. And we will return null. Let's come back here. What do we need here? Of course we do. We need a chat client. So let's go ahead and get our chat client in here. Get mapping public string short. Let's say chat client. Prompt and our user. And we're just going to say, when did the first human walk the moon? Okay, I like that. Let's say call and content, right? So what is going on here? Annotations are not allowed here. Why not? Public string short. Oops, I guess we cannot call something short. I forgot about that. Okay, so yeah, because I was trying to return a short. Okay, so this is pretty good. Let's do something a little bit longer. Let's say long prompt. And then in this one, write me a 1,000-word short story about a robot. I like that one. Okay, so those are some good suggestions. So now what I want to do is go ahead and fire this up. And we have something going on. Failed to set up, container networking, driver failed, program, bind for 3000 failed. Port is already allocated. Okay, so something's running on 3000. And I know what that is. If you were in our last section, we were talking about observability. And over in Docker, we have 3000 running. So let's go ahead and stop this. And let's try and rerun our application. Ambiguous mapping, cannot map chat controller. So I did something wrong here. Chat controller. Chat controller. Oh, did I just copy that over? Okay. So let's try this again. Nothing like a little fun live debugging. Okay, we are up and running. Let's go ahead and send a request to 8080/short. Okay, the first human to walk the moon was 1969, Neil Armstrong. So let's do long. All right, and so we have our 2 requests. Let's see if we can go ahead and take a look at these. So remember, if we go back to our compose, here we go, compose.yaml. So Prometheus is running on 9090 and Grafana is on 3000. All right, so here we are in Prometheus. We can go ahead and enter some expressions to kind of search for some of these things. So I can query on a bunch of metrics that are exposed by the actuator as I start typing out AI. I can see some of these. Let's see, Gen AI client token usage total. If we go ahead and look at that, we can see a few here. So 1199, 1163, and 36. Again, these are kind of boring on itself, right? But they are important. This is the place where we collect all of the data from the actuator and store it in some time series data. But again, if you want to kind of check this out, you can go through and look at a whole bunch of different metrics that we are storing here. And again, you didn't have to do any of this out of the box. These are all being exposed for you. So now let's look at Grafana. All right, so here we are in Grafana. Again, remember we set up an admin for a username and password. Sure, we want to set a new password for that. I'm going to use the super strong password of password. And now I get in there. So now we have our Grafana dashboards. This dashboard was loaded because of that configuration that we went ahead and pasted in. So let's just see if we can continue this. Let's try another short one. Another short one. And maybe a long one. And see if we can't start to collect some metrics. So again, Grafana, there's a lot going on here. I'm certainly no expert on this, and I'm not going to go too deep into this. Really just what I want to see is some of this total AI requests, average response time, success rate, error rate, token usage, total tokens used. This is a lot of great information. Let's see, refresh. Last 5 minutes, refresh, auto. All right, I wonder if we just change the UID to something like that. Let's save and test that. We go back to home. Okay, so I just didn't have the right UID in the dashboard configuration. So now we see 5 total requests. We see an average response time of 21.2 milliseconds. Here's our success rate, our error rate. This gets interesting, token usage. So here we see prompt tokens, which is the input, and the yellow is the completion tokens, the response from the LLM. So not spending a lot on prompts, which is good. That's something we want to take a look at. Here we're spending a little bit more on responses. And then response time distribution. And then instead of breaking them down by prompt and completion, we get the total number of tokens, and we can start to see those. So this is really good. This is important for any application, to be quite honest. You don't want to just put something in production and hope that it works. When it comes to AI applications, we want to see these things like response times, AI requests, token usage, total tokens. These things are going to be very important, especially when we start putting something out there that is taking high throughput and using lots of tokens. That is going to cost us. So we want to make sure we are on top of that. All right, so I think that's all I wanted to cover in observability. Again, we could go a lot deeper in this section, but trying to cut this down a little and keep this a little bit concise. But if you have questions on observability, please feel free to ask them. With that, let's move on to the next section. All right, next up, I want to talk about model evaluations. And we're going to start here with kind of defining what deterministic and non-deterministic is. So when we evaluate AI models, the distinction becomes critical. On the left, we have a deterministic behavior, very predictable, repeatable outcomes. On the right, non-deterministic behavior, where identical inputs can produce different outputs. So traditional software testing works like clockwork. Run the same test with the same input, get the same result every time. This makes evaluation straightforward. We can create test suites, run them repeatedly, and trust that the results are consistent. But modern AI models, especially large language models, are fundamentally non-deterministic. Ask ChatGPT the same question twice, you might get 2 different answers, both potentially correct. This throws out our traditional evaluation methods right out the window. So the bridge to evaluation challenges. How do we evaluate something that's inherently unpredictable? This is one of the biggest challenges that we face in AI today. So why evaluate AI responses? Let's talk about the challenge. Well, AI models can generate plausible but incorrect responses, also known as hallucinations. Traditional unit tests don't work for AI-generated content. This becomes, if we're just asking for some type of response, we don't know what's going to come back. Now, we can get into like some traditional unit tests with maybe sentiment analysis, which we'll take a look at, but usually traditional unit tests don't work. And we need a systematic way to validate the AI output quality. We can't just throw this out in the wild and hope for the best. So what is the solution? We use AI to evaluate AI responses. I know, sounds kind of crazy, right? Structured evaluation frameworks and automated quality checks in your pipelines. So let's take a look at what Spring AI gives us out of the box for an evaluation framework. There's a core interface. It's a functional interface called the evaluator. Has a method in there called evaluate that takes an evaluation request. An evaluation request has the original user input, the contextual data. So an example might be from a RAG pipeline, and then the response content from the AI model. Currently, there are two key evaluators. The first is the relevancy evaluator. The purpose is the AI response relevant to the user's question? If I asked for an example of, say, a Java application and I got back about a short story about dogs, that's not very relevant. So this is really best for RAG when we are using those RAG pipelines to provide that contextual, that context to the LM. Are we staying on topic here? This is good quality control for chatbots that we're kind of deploying out into the production. Then we have the fact-checking evaluator. Is the AI response factually accurate? This is best for detecting hallucinations, verifying claims against some kind of source material, or content validation. So let's take a look at the relevancy evaluator and dive a little bit deeper. What does it do? Well, it compares AI responses against retrieved context. Asks, does this response answer the user's question? And ultimately returns a yes/no evaluation. And so a default prompt template for this might be your task is to evaluate if the response for the query is in line with the context information provided. Answer yes if relevant, otherwise no. For fact-checking, verifies claims against provided documents, detects factual inaccuracies and hallucinations, can be specialized models like the bespoke mini check. This is a model that is accurate, small, fast, and cost-effective. So you will see this at times in test environments. If you wanted to run this, like say in your test environment, maybe you could use something like test containers to spin that up. So the evaluation format is, here is the document, here is the claim or the AI response, is this factual? Now, we can test some deterministic AI tasks, like classification tasks. More predictable outcomes, traditional testing approaches. So some examples of this might be sentiment analysis. I am going to feed you some examples of positive, negative, and neutral reviews. Please go ahead and review these next ones, and we should be able to determine that. Content moderation, is the response safe or unsafe? Intent detection, is this a question? Is this a request? Is this a complaint? So when we test deterministic AI tasks, we can use our normal unit tests here. So we have test sentiment classification. Here's some positive text. I love this product. When we classify this text, we can assert that the result is equal to positive. The key difference here is the expected outcomes are known and consistent. So that's a few things about testing some of our functionality in our generative AI applications. We're going to look at 3 demos of this using the sentiment analysis. Actually, I might even jump into a 4th. We'll take a look at structured output tests. You can run that as well. And then we'll look at a relevancy evaluator test and a fact-checking test. All right, so here I am back in the AI workshop code that we've been working along with. And I'm going to drop a new package in here called evals so that we can test some of this. So if we look at this, there's a sentiment, which is basically positive, negative, or neutral. And the review service, we get a chat client just as we normally have been. Now, one difference here is we can set some default options. In this case, I'm saying the OpenAI chat options, I'm getting the builder. I'm setting the temperature to 0.1. So the temperature when it comes to large language models is the scale of creativity. 1.0 being very creative, 0.1 being more deterministic. So in this case, I want it to be more deterministic. I'm setting a temperature for any client that we use. We're only using one here, but any other method that uses client would use that temperature as well. So I have a system prompt. Classify the sentiment of the following text as positive, negative, or neutral. Your response must be only one of 3 words. So I have that system prompt. I send in a review. I call it, and then I get a sentiment back. And again, that sentiment is one of those 3 words. So we could fire this up and test this out, but I want to write a test against this so that we can show kind of a traditional unit test against this. So let's go into test. Let's go in here and create a new package. We'll call this evals. And in evals, we're going to create a new Java class, and we'll call this sentiment analysis test, right? So this is a class. We're going to say this is a Spring Boot test. I might get rid of that. No, I actually need that because I'm going to bring in that review service. So we'll just say auto-wired review service. And then we can write a couple of tests here. So I'm going to say test void test positive sentiment. No, let me do this myself. Okay, so let's say positive review is equal to I absolutely love this hotel. It was amazing. Sure, guess so. So then we use the review service to classify that. We get positive, rename to that, yes. And then we get a sentiment back from this. So we should be able to now test this. We can say assert equals sentiment. All right, yes, please import that static method. So we pass in sentiment.positive and then our sentiment. And let's just give it a message. Cool. All right. So that's one. Now let's see if we can go ahead and run this test. Cool. That passes. All right. So just for the sake of brevity here, let's just go ahead and paste a couple more in. So now we have a negative sentiment and a neutral sentiment. Let's just make sure all 3 of these pass. Cool, and there we go. So that's our first one. That's kind of our deterministic. We expect these outcomes, so we can write kind of our traditional tests against those. I will show you one more before we get to the non-deterministic side. Again, I think I'll just kind of copy and paste this in here. This is not our evals, but what was our output? Yeah, so let's say new package output. Let's create a new class here. We'll call this the structured output test, right? And then let's just copy and paste this in here again. Not the interesting bits here. So we have a client test config. So yeah, let's go ahead and add that because we're going to use this for other ones. So let's say, oh boy, I should have moved that into here. So let's do that because, no, I don't care. Let's put this in client test config. And that is just going to look like that. That's our test configuration to create a chat client. We get the builder, we build it, we create a chat client from that. So in our structured output, oh, that is not our client, chat client. Let's refactor. Okay. Okay, now we pull that in, we import that. Now we get a chat. So I don't know why I did that here. This would get auto-wired in. right? And actually, I could probably just auto-wire this in here, right? So yeah. So what we're doing here is we're testing the get itinerary. Here's the destination. We're actually making a call to the large language model. What's a good vacation plan while I'm in destination for 3 days? All I'm checking is that the structured output matches the itinerary. So, hey, the result should not be null. We should have an itinerary. We should have a list of activities. So let's see if we can go ahead and run this one. And that worked. So this is more of an integration test. You could easily just kind of set the response and make sure that's matching that. But I like this kind of test here, just testing some of our structured output responses. Okay, so that's it from kind of the deterministic side of things. Now let's take a look at maybe the relevancy evaluator. So let's go in here and let's create a new test. Let's call this the relevancy evaluator test. And this is going to be an @Spring Boot test. And the first thing that we'll need is that relevancy evaluator. So yes, we'll call it that. I'll set up a before each here, and we'll say this is setup. Sure, but what this relevancy evaluator is going to take is a chat client builder. So it's going to take that builder. So we need to get access to that. So I'll go ahead and auto wire that in here. So chat client .builder. Sure. And then we pass that in. So now we have a relevancy evaluator. So we'll write one of these together, and then I'll kind of copy and paste them in. Actually, it really is not interesting for me to write these. So let's just take a look at one. So I have a, looks like I need a helper method. Yes. So I have this user query. What is the capital of France? Here is some context that I may pass along. France is a country in Western Europe. The capital of France is Paris. French is the official language spoken in France. And then I'm just kind of simulating here an LLM response saying the capital of France is Paris. What I do with that is I take the evaluation request. Remember, that takes the original user's query. It takes any context, and then it takes the LLM response. Now, if we jump into this, you can see that this takes a list of documents. And this is, again, because if we were using something like RAG, we want to pass those documents as context. So I created a quick helper method here to basically take in some context strings. This is a list of, and just map these over to a list of documents. So once I have that evaluation request, I can use the relevancy evaluator to evaluate that request. And then I assert true, the response.isPass, because remember it's, here, let's look at this. Let's look at what this returns. So this returns an evaluation response, and this is basically going to be pass or not. It has a score, it has some feedback and some metadata about it, but really all we're doing is we want to make sure this passes. Is this relevant, right? So let's go ahead and run this. And that does pass relevancy. Now let's look at an example that has nothing to do with that. So if we look at this one, again, we're asking what is the capital of France. Here's some context. The response is, I enjoy eating Italian pizza. Clearly, this is irrelevant. We do the same things. Response should be relevant. We're asserting false. Response.isPass. Response should be actually relevant, right? So let's go ahead and run this one. And so this passes. Yes, this should be false. This is not passing. This is not relevant to that. So we go ahead and we get a check mark there. So that's our relevancy evaluator. Let's take a look at one more test that we can write, and that is going to be our fact-checking evaluation test. So let's go ahead and create a new Java class. We'll call this fact-checking evaluator test. So you can do a couple of things here. You could use the same LLM that you are using to fact check itself, but that doesn't make a lot of sense, right? So in this case, I may want to use a different large language model to go ahead and check this. And as I said, one thing you might want to do is use something, again, there's that bespoke mini model out there that runs really fast. When I'm running tests locally here, I might want to run them on a local model. So I'm going to show that as an example today. Now, to get that local model running, I am going to have to use test containers. So I am going to, again, this is reliant on you running Docker Desktop, but if you have it running, that's okay. If not, you can follow along. So I am going to bring in some test container support here. So we are going to say that and that. So now I have test container support for Spring AI, for JUnit, for Ollama, because we are going to use Ollama in this. And so we are going to say at Spring Boot test, at test, did I reload this? I don't know if I did. Yes. Okay, so now I have test containers. So let's go ahead and bring a few things in here. So I'm setting a static final string Ollama image. So I'm pulling Ollama from test containers here, loading that image. And basically because of the newest, like the kind of newer versions of Spring Boot, have really simplified this with test containers. So you can just add the at container, the at service connection. We give it a name. So spring.ai .ollama.base-URL. And this kind of sets that, that URL there. And then we bring in the fact checking evaluator. Okay, so now that we have that, let's go ahead and take a look at a test here. Void passes when claim is true. String context document. So it says the Eiffel Tower is a wrought iron lattice tower located in, oh, I'm going to butcher all of this. So, all right, so we have this fact-checking evaluator. We have this claim. This is the AI response, basically. The AI response is the Eiffel Tower was completed in 1889. So for fact-checking evaluator, we're going to pass the user text. This can be the original user query or the claim itself. For simplicity, if there is no original query, again, the list of contextual documents, and then the response. So the text is, when was the Eiffel Tower completed? Here's some context documents, and here's the claim. So what we should see is the evaluation response evaluates this, and we want to see that this is true. This is a pass. Cool. So that's our contextual document. This is our response. So let's see if this runs. All right, so we got that one to run. Let's see if we can get one on the other side of this. Let's say that we had this, and then the claim is the Eiffel Tower is located in Berlin, Germany. So that is not true. So we are saying, where is the Eiffel Tower? And then we are asserting false here. That should not pass because that is not factually correct. So let's see if we can go ahead and run that. And that passes. So great. I think that's all I wanted to get into, just to kind of give you some intro into testing. We have this eval package. Again, you can pull this down and check this out from the repo. We have our structured output test. That's kind of a generic or like a normal test that we're used to writing. We have our sentiment analysis test. This is a little bit more deterministic because we've basically told on a review service that it can only be one of three answers. So we know what we think it should be, and we are just testing that that is correct. And then we have our relevancy evaluator. Is this relevant to the user's query? If it has nothing to do with it, then it's just giving a little bit more of a sanity check on some of our tests here. And fact checking is, let's make sure we are trying to cut down on some hallucinations. Again, especially in like your organization, if you're going to be getting a lot of the same types of questions, these are tests that you can run to make sure that these are getting correctly answered. So with that, that is all for testing. Again, we can dive a little bit deeper. I'm trying to stay a little bit concise here because this is getting pretty long. But let me know if you have any questions on evaluating model responses. All right, well, if you made it all the way to the end of this course, I want to first congratulate you on sitting through all of this content. I know it's a lot to take in. Hopefully you went through and used some of those tips that I gave you at the beginning on how to go through the course, break it up into different sections, and really kind of take what you've learned and build something out with it. I've had a lot of fun. We're not done yet, though. I want to talk about a few things. What did we learn today? Some key takeaways, some resources that you can walk away with as you continue your exploration into the world of AI and specifically Spring AI, and then we'll go ahead and wrap it up. All right, so what did we learn today? We started off with the fundamentals of AI, explored some of those key concepts of artificial intelligence, including machine learning, deep learning, and transformer architecture that powers large language models. I said when we are in that section that you don't need to know these really in depth. I don't. It's really just to kind of know them at the surface. So when we're having conversations about AI, we understand what we're talking about. Prompt engineering. Hate the term, love the fundamental skill. It is key. It's the quality of our input directly impacts the quality of AI's output. We covered several techniques from basic to advanced, from crafting effective prompts, including zero-shot, one-shot, and few-shot prompting, as well as providing clear context and structure. We took a look at Spring AI. What is it? We saw how Spring AI simplifies integrating artificial intelligence capabilities into Java applications. Again, it's not just a facility for making REST API calls. It is going to solve a lot of the problems that are going to come up as we start to build these generative AI applications. And it provides abstractions for interacting with various AI models for chat, image, audio, and more. Ooh, what a great section this was. I had a lot of fun putting this together. Overcoming the LLM limitations. We addressed the inherent limitations of LLMs. It's good to know these things because you can go in understanding where it's going to fall short so that you can kind of fix that, right? Such as hallucinations, stale data. We discussed strategies like retrieval augmented generation, tool calling, and MCP, and so much more. So I hope you really enjoyed that. And then we talked about evaluating AI responses. We learned that traditional testing methods are insufficient for non-deterministic AI outputs, and explored how to use the evaluator tools in Spring AI to check for relevancy and factual accuracy. So what are my key takeaways from this course? AI is a tool to be mastered. Large language models are powerful but not magical. They're pattern matching machines that predict the next word. Your success in using them depends on your ability to communicate effectively through well-crafted prompts. On that same line, I said this earlier in the course, right? Prompt engineering is a developer's skill. I'm trying to really harp on this. Let's not just command the AI. If you are talking to a junior developer or a fellow colleague, you wouldn't just command them to go do something. Instead, you might want to lead them in a certain direction. Teach them what you are trying to get out of this. So providing context examples and clear structure to your prompts will dramatically improve the quality of this response, right? Start saving effective prompts as you create them. Spring AI is your gateway. Spring AI simplifies the process of integrating AI into your Java applications by providing portable API that can work across different API providers. This means that you can build with AI without being locked into a single vendor. And this is so important for me. And I love the fact that I can switch out models. I also love that I can use multiple models in the same application, writing the same code. I'm not like learning new code per model. So that's really important for me. Don't trust, verify. LLMs can hallucinate and provide incorrect information with confidence. You must build your guardrails in. We talked about some of those guardrails, right? From a system prompt standpoint, being able to say like, this is your role, this is who you are. These are the types of questions you're going to answer. So it's not just like a general chatbot. We can also use techniques like retrieval augmented generation to ground the model with your specific data. Implementing evaluation checks to validate the accuracy and relevance of AI responses. Finally, from my key takeaways, start building now. The best way to learn anything is, by doing something. So I hope that throughout this course, maybe you learned something new and you went off and tried to build something. If not, this is a really good time to do so. Begin with some kind of simple use case, get your API keys and start experimenting. Use the provided resources like Spring AI workshop code and documentation to actively code along and build your own project. All right, speaking of resources, I got a few that I want to go through here today. Again, github.com/danvega spring-AI-workshop. That is all the code we went to today. Even if it's not in there, it'll be in a folder like the observability one is in a README that points to another GitHub repo. Okay, and then the Spring AI reference documentation. You know what I'm going to do that I don't have yet? In the Spring AI workshop repo, I'll put a resources, either be in a resources.md, probably there. I'll put these and more to kind of link you to things in case I update that, but these will be in there. The reference documentation, Spring AI source code. There's an examples repo for Spring AI. Ooh, Spring AI community. I want to show you this one. So this is a really awesome resource over on GitHub, Spring AI community projects, a community-driven organization for building Spring-based integrations with AI models, agents, vector databases, and more. So there is the wiki, the community repository, the upstream Spring AI project, where you can find more about Spring AI on Twitter and Blue Sky. If you want to propose a new project, you can do so here. It's not just a project of like, here's some code. It could be other things. One of the projects I started a while back, it was on my repo and we moved it over here to the Spring AI community, is Awesome Spring AI. And this is awesome, obviously. This is a whole lot of curated list of resources, tools, tutorials, and projects. And this was contributed to by the community as well. So you can dive in here. Here's some blogs, here's some books, articles, a whole bunch of stuff. So this is really great. Go through and look through the projects and see if there's anything that kind of sticks out to you. Again, my website, all of my socials are on here if you want to get a hold of me. If you want to stay in touch with me, I do write on the blog. I have a newsletter where I kind of tell you about what I'm up to and the content that I'm creating. If you want to find out where I am speaking next, you can go on the speaking page and see what is upcoming for me. Some courses, which this will get added to. I'll use this page. People always ask me like, hey, what monitors are you using or what camera are you using for your videos? So any of that information is here. And of course, everything has dark mode. So that is my resources. Again, also Spring Office Hours. That's another going on. I'll put that in the resources. Yeah. Speaking of books, my friend Craig Walls, who I will be doing a workshop in the fall of 2025 with, an 8-hour workshop on Spring AI, has a book coming out. And manning.com/books, Spring AI in Action. That is going to be a real good one. I can't wait to get my hands on that. Whew. Last but not least, I just want to say I am thankful for being your teacher. Thank you for taking time out of your schedule to go through this content. I really hope you learned something. If you found anything confusing, you have access to me. Please reach out to me. And I can't wait to see some of the things you guys build. I don't know if it comes across, but I love what I get to do. And I am appreciative that you went on this journey with me. And there will be more journeys, so I hope you join me again. With that, I'll say happy coding, friends. See you guys.